Hi all, welcome to one more lecture. In this lecture, what I am going to discuss with you is what the subject econometrics is all about. Why we need a subject econometrics when we have a well-developed mathematical economics and statistics. What are the subject matter of econometrics and how the econometrics has evolved over a period of time. So, majority of you may not have learned the econometric course before. And some fellows or some people, they might have learned the things when you were studying for your undergraduate program or from somewhere else. Okay, so first of all, if you have not learned econometrics before, let me tell you one thing, that learning econometrics is just like learning a new language. So when we learn a new language, we may feel a lots of constraints, and everything will be unknown to me and new to me. For example, it's alphabets. We don't know the new language alphabets, how the words are pronounced, how the sentences are constructed, what are the things that we have to follow when we speak, or what is the grammars of these things. Okay, these things we doesn't know when we learn a new language. And if we have read, or if we just refer certain books in how to learn this language, then we feel that there are large number of books. All these books have written how to learn this language in different way. Whatever the things they have used, the expression they have mentioned, everything will be different from different authors. Okay, similar kind of experience you may have when you learn econometrics. Basically, learning econometrics is not a big thing. It is a very simple thing. But when we started to refer the books, we feel that whatever the things that they have written by, Gujarati is entirely different from whatever the things that has written by Woolrich. And these two books are entirely different from William Green econometrics book. And if you take the Baltagi's book, that's also different. So we may feel that all these books are written on basic econometrics, but in a different kind of manner, or different way they have written their subjects, and different way they have approached the subject econometrics. This is the first thing, and this is the most difficult thing when we started to learn econometrics, or as a beginner, this is the one of the most difficult thing. Okay, so even though the expressions, notations, and the way that they have write the things are differ, but the ideas and concepts are almost one and same. The only problem is they have written the things in a different manner. Okay, so let me in the beginning itself, let me suggest you that if you want to learn the things, you just focus on one books. Okay, just focus on one book. It is better to go with Gujarati, basic econometrics Gujarati, because if we don't have that much mathematical knowledge, then it is better to go for basic Gujarati. And there is one more book, that is Econometrics with Examples. So you can go with these two books simultaneously, even though the books are two, they have written in the same manner, as because both Both the authors are one and same. Okay, and if you have good mathematical knowledge, and if you have a very thorough knowledge in matrices, then it is better to go to William Green Econometrics book. Okay, yes. So let me suggest you one thing. Learning econometric, as I said, you say something like learning a new language. This is basically because of learning econometrics, or the modules or the concepts in econometrics are cumulative in nature. That means whatever the thing is there in the first chapter, its continuation is there in the second chapter. Okay, so if you don't understand what is there in the first chapter, then you may not get what is there in the second chapter. Okay, that's why I suggest you don't miss any classes or any lecture or in videos. Okay, if you want to learn the things, you start from the basic itself. You will learn the things continuously. Okay, yes. Then coming to the subject, what is an econometrics? Econometrics is a neologism which is derived from two Greek words, oikonomia and metron. Oikonomia is nothing but economics, as we know that, and metron means measurement. Okay, so oikonomia plus metron, economics plus measurement. So literally it means that economic measurement, or measure the things in economics. So if somebody asks you what's econometrics, is nothing but econometrics is measure the things in economics, or economic measurement. Okay, so as a subject, if we refer some books, we can see econometrics is a new branches of economics. So these books have written in some years back. That's why they are saying like it is a new subject. Okay, but I would like to say that it is not a new subject. Okay, it is basically the subject has evolved or derived or developed from 1930 onwards with the formation of the International Econometric Society and the publication of the Journal of Econometrica. Okay, but still we say that it's a new subject. So don't say that it's a new subject. Okay, but we can say it's a neologism. Okay, so now it is 2020. This has started to develop in 1930. Okay, so almost 90 years have gone. Okay, so don't say that's a new subject. It has a 100 years of existence in the real world. Okay, so let me tell you what is the subject econometrics. Econometrics is a new subject, or it's a subject, or you can say that it's a branches of economics. Okay, but this branches doesn't have a single existent. It's a combination of different subjects. It is not a single subject. Okay, the name itself says that economics is economics plus metrics, or economics plus metron, or measurement. Okay, so usually what we do in order to measure the economic thing, or in order to measure the things in economics, we usually go to mathematics or statistics. Okay, so the application of mathematics and statistics in order to learn the economics is basically what is econometrics is all about. Okay, econometrics is nothing but a subject which combine three things: economic theory, mathematical economics, and statistical methods. Okay, so economics is a subject which is a combination of economics, mathematics, and statistics. I hope it is clear. Okay, or you can say application of mathematics and statistics to economics, or to economic theory. Okay, and if you look at in other branches of science, especially to social science, we can say that this kind of measurement subjects are there in almost all branches of science and social science. In sociology, there is a sociometrics. Psychology, there is a psychometrics. Anthropology, there is a anthropometrics. In chemistry, there is a chemometrics. Okay, so in almost all branches of science, there is this kind of a measurement subjects are there. Okay, so all these subjects are a new subject or a subject that is combined certain tools in mathematics and statistics and applying this tool into that concerned subject. Okay, so one thing in this slide, what I am trying to say that econometrics is derived from two Greek words, oikonomia and metron, literally mean economic measurement. What's econometrics? Econometrics is a combination of economics, a branches of economics, which is a combination of mathematics, economics and statistics, or we can say that application of mathematics and statistics to economics. Okay, yes. Then how we can define the subject? In the same way that we have discussed now, we can define the econometrics. Okay, but different authors or different societies and dictionary has given the different types of definition, but one thing is there, every definitions or each and every definitions have given the same idea or same concepts. Okay, so the most old or the oldest definition was given by the Econometric Society. They have defined econometrics as economics in relation to the mathematics and statistics. Economics in relation to mathematics and statistics. This is the most simplest definition as well as the most oldest definition. Okay. Then the American Heritage Dictionary of English Language, they have defined econometrics is an application of mathematical and statistical techniques to economics in the study of an economic problem, the analysis of data, and the development and testing of economic theories. Okay, this is the definition given by the American Heritage Dictionary of the English Language. Okay, and you can see number of definitions. If you look at each and every book, they have given their own definition. Okay, but this is the most acceptable definition or most commonly followed definitions. And one more definition is there, that's one of the most accepted definition given by Madala. According to Madala, the application of statistical and mathematical tools to the analysis of economic data with a purpose of giving empirical content to economic theories and verifying or refuting them. That means it's the same thing, application of mathematics and statistics to economics for what purpose, or economic data for what purpose? To give the empirical content to the economic theories. Okay, and verify the theory. You have to say that and verify the theory or refute the theory. So in order to verify a theory, in order to accept or reject, or in order to verify or refute a theory, we have economic data. Okay, so applying the mathematical and statistical tool to the economic data is called the econometrics. I hope I hope it is clear for you. Okay, yes. Then why we need a separate subject? There is a need of having a separate subject, econometrics? As I told you in the beginning, we have a well developed mathematical economics. Okay, it is oldest as economics. We have a economic statistics, that is also oldest as statistic. We have a mathematical economics or mathematical statistics. Okay, then we have economics or economic theory. We have these four well developed subjects. Then why we need a new subject, econometrics? Have you ever think about it? Okay, let me examine this. Okay, so economic theory, what economics or economics theory says? Economics or economic theory will give us qualitative statement, just like demand theory or consumption hypothesis. Okay, in demand theory, what it says, other thing remain the same. Whenever the price increases, the quantity will also decreases. Okay, what consumption hypothesis, Keynesian consumption hypothesis, whenever the income increases, consumption will also increases, but the increases in consumption will always less than that of the increases in income. Okay, this is the concept given by the Keynes. Okay, so these two things are purely qualitative ideas or qualitative statements. Okay, so this is the duty of in economics to give some qualitative statement. Okay, then it is the duty of a mathematician to convert an economic statement to a mathematical model. What a mathematical model is? A mathematical model is a simplified abstraction of a real phenomenon. If you have a real big phenomenon, okay, that phenomenon can be simplified using economic or mathematical model. Okay, so just like QD, or Q is a function of P. With three words Q, F, P, we can model the demand theory with three digits, or with three letters we can model, or we can simplify whatever the demand theory says. C is a function of Y. This is the big idea of Keynes. The Keynesian idea can be simplified into an economic model using two letters and one function. Okay, so it is the duty of a mathematical economist to convert the economic statement that are qualitative in nature to economic model, or to simplify the economic statement into certain mathematical models, functions or graphs or something like that. Okay, yes. Okay, then what's the duty of economic statistics? What is economic statistic and mathematical statistics? There are two types of statistics. Okay, the collection, then collection of the economic data, classification of the data, disseminate the data, process the data, and analysis of the data, or in order to describe the features of the data set. These are all come under the economic statistics. The main duty of the economic statistics is nothing but to collect the economic data and process it for the analysis purpose. Okay, then what's the duty of mathematical statistics? The mathematical statistics will supply certain tools to analyze the economic data. For example, regression is a technique which is given by mathematical statistics. Okay, so the mathematical statistics will club mathematics plus statistical ideas. Okay, so we have all these four different branches of sciences. Okay, then why we need an econometrics? Okay, so econometrics, what econometrics is doing now, econometrics will take everything from everywhere, or econometrics will take something from economics, something from mathematics, economic statistics and mathematics statistics, and the econometrics will make their own ideas or their own theories, their own tools to verify an economic theory or a statement made by economics. Okay, so it's a duty of econometrician to verify whether an economic theory or economic hypothesis or an economic relationship is true or not. Okay, so this verification will not be done by economist or mathematical economist or economic statistician or mathematical statistician. Okay, economic theory will give a statement. Mathematical economics help us to convert the statement into a model. Economic statistics will help us to collect the economic data, and mathematical statistics will help us to analyze the data using certain standard statistical tools. Econometrics will club all these things and help us to verify an economic theory or an economic relationship or economic hypothesis, or to evaluate an economic policies. Okay, so this is, for this purpose we need a separate subject called econometrics. I hope it is understood. Clear? Yes. Now, what is the subject matter of econometrics? What is the subject matter of econometrics? What are the things that comes under econometrics? There are large number of things that come under the econometrics. Nowadays, almost each and every large number of techniques are there that's come under econometrics. Okay, but all these techniques can be broadly categorized into or broadly included under the four definitions. Okay, first definition means define the subject matter. Okay, first thing, econometric is the statistical and mathematical analysis of economic relationship. Okay, Mathematical and statistical analysis of economic relationship. Look at the example, Keynesian consumption function. This is a relationship between consumption and income. Okay, Keynes said that consumption and income relationship are proportional to the consumption. Whenever the income increases, consumption will also increases, but less than proportional to income. And due to this fact, whenever the income increases, APC will down and MPC will always lies in between 0 to 1. So this is the basic idea that the Keynes has given. We want to check whether the relationship said by Keynes is right or not. Whether this relationship hold true for a particular group of people, for a particular period of time, or a particular place. That we have to check. For that purpose, we can use econometrics. With the use of econometrics, we can easily understand. We can easily say that whether the relationship set by the Keynes is true or not. Okay, so that is the main duty of the econometrics, to analyze an economic relationship using statistics and mathematics. Clear? Second one. Science or econometrics is a science of empirically verifying economic theories. We have a large number of theories in economics. In microeconomics, macroeconomics, you take international trade, development economics, you take any sub-branches of any sub-discipline of economics, you can see a large number of economic theories. Okay? Economic theories need to be substantiated by the economic data. Okay, so we have theory on the one side, we need to have measurement on other side. A theory without measurement or a measurement without a theory, both are useless for economics. So we have certain measurement, but we don't have a we don't have a theoretical background, we don't have a proper theory in order to describe the situation. There is no use. We have a well-developed theory, but we cannot measure the theory. Both are useless. Okay, so for example, you can take any theories. Okay, let me take here Keynesian demand function, Keynesian money demand function. What Keynes said about the people holding of money. Demand for money is nothing but desire of a people to hold money with them in cash or bank. Okay, is functionally related to functionally and positively related to income of that person and the existing market interest rate. Okay, M is a function of Y plus income is positive rated, comma interest rate negative. Okay, that means if a person is having more income, he will hold more money. If the existing interest rate is very much high, then the opportunity cost of holding money will be very high. Okay, that's why people will reduce their holding and they will deposit in the bank. So this is a basic idea that the Keynes has given in his liquidity preference theory. Okay, so suppose if we want to verify whether the Keynesian idea of demand for money is working or not, or whether it is true or not. Okay, so that we can take money demand or money supply data on money demand and money supply, that because money demand is always equal to money supply. Okay, so MS money supply we can take M3. Okay, then we can take the GDP as a proxy for income, and then we can take any of the market interest rate. Then we can apply certain tool to this and we can verify whether Keynesian idea about the demand for money is right or wrong. Okay, so verification of an economic theory is the subject matter of econometrics. Okay, analyzing an economic relationship with the use of mathematics and statistics is a duty of econometrician. Clear? Yes. Third subject matter. Econometrics is a powerful econometrics will supply powerful tool to forecast or predict the future value of an economic variable. If you look at the newspapers. In each and every day we can see a large number of predictions of forecast. Just like the GDP is likely to increase in the coming year, or inflation is likely to fall into 2% in the coming quarter. The population in Kerala is expected to be negative in the coming census. Okay, so this kind of ADB is forecasting. World Bank, IMF, large number of international organizations, they are also giving some forecast about different economic variable. Okay, so this is basically they are examining the past data and they are giving and they are reaching certain idea about the future value of an economic variable. Okay, so the forecasting or prediction is done by the econometric tools. Okay, so forecasting an economic variable is a subject matter of econometrics. Clear? Yes. The last one, econometry is the art and science of making quantitative policy recommendation to the government. Okay, what is the duty of a government? To make some policies. For what purpose government is making policies? In order to solve certain economic problem, we need economic policies, so the government is devising economic policies. Okay, so who is behind these economic policies? Economist. Okay, so the economists, they are not simply giving some policies. They have studied certain problems in detail, and on the basis of that study they have arrived at certain conclusions, and on the basis of their study they have given some policy suggestions. Okay, but the policy suggestion should be quantitative in the nature. For example, suppose the government wants to decrease the smoking consumption or smoking behavior among the youth. Okay, and then the government approached certain economists. The economist suggested you increase the tax on cigarettes. Yes, but the government may accept this proposal. Yes, we can increase the tax, but how much? The government will ask how much. If we increase the tax from existing 15% to 20%, how much smoking behavior will, or how much pupils how much smoking behavior will be decreased? Okay, so government wants, if the tax rate is increased from 15 to 20, the 20% of now the total number of smokers in the country is 20% of total populations. This will decrease to 15%. Okay, so the government always need this kind of a quantitative policy recommendations. Okay, you can there are large number of policy recommendations are there, and all these are not merely the qualitative statement but the quantitative statement, okay, or quantitative policy suggestions. Okay, so all the government body, all the business, okay, suppose if a business wants to increase the sales, okay, then there will be an economist in the firm or in the industry. The manager approach the economist, what we can do, our sales are decreasing, what we can do? The economist suggests you just increase the advertisement cost. Yeah, that's a good idea, but the manager will ask how much. If we increase the advertisement cost by 5%, how much sales we can expect to increase? Okay, so this kind of a exact quantitative suggestion that an economist want to give to the corporate sector or the government. For that purpose also, the econometrics only will help us. Okay, so these are all the 4 different areas of the basic subject matter of econometrics. Okay, I hope it is clear. Okay, then what are the ingredients of econometrics? As I told you, econometry is a combination of 3 subjects: mathematics, statistics, economics. Okay, but nowadays these 3 subjects are not sufficient to do an econometric experiment, because econometry has developed like anything. The tools and methods in econometrics is developing like anything. Okay, some economist says that the growth of the econometric subject is more than the growth of the economics. There are people they are arguing like that. Okay, or because of these increased concepts or increased tools in econometrics, the computing power or the computer softwares are necessary to do certain econometric experiment. Without computer, we cannot do certain econometric experiment. Okay, we can do only simple regression techniques using pen and paper. If we have 4 or 5 economic variables in our regression model, then this pen and book will not help us. For that, we need computing softwares. Okay, so the computing power is one of the crucial ingredients of econometrics nowadays. Then the computer will do the operations only. If we give some command, the computer will perform the command. Okay, but the computer will not interpret the result. So it is the duty of the econometrician to interpret the result that given by the computer softwares. Okay, so for that purpose we need interpretation skill. Okay, so the interpretation skill and this computing power are the most crucial ingredients of econometrics, along with statistics, mathematics and economics. Okay, yes. Then coming to the history of the econometrics, when and how this subject econometrics has evolved over a period of time or developed over a period of time. The origin of the econometrics is a debatable topic. Okay, so if you read the history of the econometrics, we can understand that there are certain debate over the topic how the subject is developed. Okay, but I am not going to in that detail. Okay, but I will give you certain hint about all this debate. Okay, basically, or in the initial period of time, the econometrics was inseparable from mathematics and statistics as an academic discipline. Okay, so in the beginning itself, we cannot recognize which is econometrics and which is statistics and which is mathematics. Okay, econometrics was inseparable from mathematics and statistics. But in 1931, Ragnar Frisch and Irving Fisher, you might be heard about this Ragnar Frisch and Irving Fisher. Okay, they have started a new society or new organization called the Econometric Society in 1931. So after the formation of this society in 1931, the econometric has established or separated from mathematics and statistics. Okay, so the separation of econometrics from mathematics and statistics has done by a society called Econometric Society in 1931. Okay, and econometrics has recognized as a branches of economics only after 1930s with the foundation of 3 different set of pupils or 3 different organizations. Okay, so econometrics has established as a new sciences with the help of 3 different societies or groups. Okay, so these 3 group has contributed to the development of the econometrics, and they are responsible for establishing the subject as a branches of economics. Okay, who are all they? The first one, as I said, the Econometric Society. The most crucial role has been done by the Econometric Society, which was established in 1931 by Ragnar Frisch and Irving Fisher. Second one, Coles Commission in the United States. And third team is the Department of Applied Economics, Cambridge University and England. Okay, so these 3 people or these 3 sector or this 3 group has played a very pivotal role in developing econometrics as a new subject. Okay, who are all the Econometric Society, then Coles Commission in US and Department of Applied Economics in Cambridge University, England. Okay, And there are debates over who is the father of the subject economics. In every subject there is a father, okay? The father means nothing but who has contributed to the development of that subject, okay? In econometrics also there is a debate like that, okay? And the term econometrics was first used by Powell Siomba in 1910s. In 1910, Powell Siomba has used the term in his book, has used the term econometrics in his book. Okay, but I don't remember the book name. Okay, but Ragnar Frisch is credited for coining the term and establishing the subject. Even though the word econometric was first used by Powell Siomba in his book, but the econometrics has established as a subject by the Ragnar Frisch, and he coined the term econometrics. Okay, so he is responsible for establishing the subject econometrics as a new discipline, even though the term was first used by Powell Siomba. Okay, so some people say that Powell Siomba is the father of the econometrics, but most of the people, the most accepted thing is that Ragnar Frisch is the father of the econometrics, because Powell Siomba has just used the word, but Ragnar Frisch has developed a new subject, and for that purpose he has developed a society called the Econometric Society, and he has started to published a journal called Econometrica in 1932, I think. Okay, that we will see later. Okay, but in the history of econometrics, R.J. Epstein, he said that Henry Moore as the father of the modern econometrics. He said that, Epstein says that, not the Ragnar Frisch, but the Henry Moore is the father of the modern econometrics, because in 1911 he has attempted to give a statistical evidence for marginal productivity theory or Euler's theorem. Okay, so in 1911 itself, Mr. Henry Moore has given statistical evidence, or he has verified marginal productivity theory or Euler's theorem using mathematics and statistics. Okay, that's why he said that Henry Moore is the father of the modern econometrics. Okay, and one of the person who has contributed to the development of subject was Havelmo. Okay, so we know that the regression, we have a regression, you might have learned that regression. Okay, so the regression is nothing to do with probability. Clear? Regression is nothing to do with probability. Okay, it is used by it is the equation of the regression model was derived using some differentiation techniques, nothing to do with probability. Okay, but what Havelmo done that everything in the regressions, he has provided a probabilistic interpretation to the regression analysis. He made everything in the regression using certain probability theories. So he integrated the probability concept to the regression models. Okay, so it was Havelmo, he has given the probabilistic rationalization of regression analysis, and it was marked the beginning of a new era in econometrics. Okay, so it was Havelmo, he has contributed, or he has take the subject into a new level. Right? So until that time the econometrics was purely a statistical mathematical subjects, but he has taken the whole economic subject from mathematics, and he has gone to the level of he has integrated the probabilities into the econometrics, and now the probability is the major part of the econometry. Without probability, the econometrics may not exist. Okay, so it was Havelmo in 1944 has rationalized regression model using certain probabilistic ideas. Okay, so this thing is also we have to understand. Then after the formation of 1931, after the formation of the Economic Society in 1931, there was some issues. The issue was basically what will be the priority of the econometrics. Okay, so the methodological issue, the first ever methodological issues appears in the field of econometrics was the applicability of probability calculus and sampling theory to analysis of economic data. Whether we can use probability and sampling theory in statistics in order to analyze the economic data. Okay, so this was the first methodological issues that the Economic Society has faced, and the answer for this question was given by Professor Havelmo. Okay, and as I told you in the last slide, there are three different group of people have contributed the subject and contributed for the establishment of the subject econometrics. Economic Society, Covers Commission, then DAE, Department of Applied Economics, Cambridge University. Okay, but all these three group have focused on their own respective areas. Okay, all of them were concentrated on a particular issue. They all are concentrated on different issues. Okay, the Ragnar Frisch, he was skeptical of the usefulness of the tool, and his concern was about the multicollinearity and measurement errors. The Ragnar Frisch is always concerned about the multiple regression model and the multicollinearity problem that arose in multiple regression model, and how to measure and how to solve this multicollinearity issue. Okay, so this was the area where the Ragnar Frisch work, whereas the Covell Commission were busy in providing a solution for simultaneity bias issue or simultaneous equation model. Okay, that we will learn. Simultaneous equation model is nothing but we have two equations. Okay, if we have demand equation, we have supply equation. Okay, demand and supply equation together determine what is P is. Okay, so using demand equation alone or using supply equation alone, we cannot establish the equilibrium price. For establishing equilibrium price, we need demand equation and supply equation. Okay, so we have two equations. Okay, such kind of economic model is known as simultaneous equation model. Okay, so Covell's Commission in US, they were busy in providing estimation. They were busy in estimation of simultaneous model. Whereas the Department of Applied Economics in Cambridge, they were busy in providing, or they're busy in developing new tools in time series econometrics. Okay, so all these three different people, they have contributed more to the development of econometrics, were concentrated on different areas of econometrics. Okay, yes. Then after, as I told you, the development of the econometry has started in 1930 itself, especially with the publication of the Journal of Econometrica and the formation of the Econometric Society in 1931. Okay, and after the establishment of the society and the publication of Journal of Econometrica, the development of econometrics has a huge impact on theoretical and empirical research in economics. The subject econometrics has a substantial impact on the research and analysis, the research and theories in economics. Okay, and now up to now, 6 volumes of handbook of econometry have been published. We have six big handbooks on econometrics. And one more interesting thing, we have to understand that we all know that the Norwegian Society is giving the Nobel Prize in economics. Okay, then to which subject economics the Norwegian Society has given more number of given the prize to the more number of times? You know which subject? Micro, macro, which subject you know? Yes, macroeconomics. Okay, so the most number of awards has won by the macroeconomics. Okay, the Norwegian Society has given more awards to the subject macroeconomics. Okay, after that 49 Nobel Prize in Economics. So out of 49 Nobel Prize in Economics given to 79 scholars till 2007 okay, 5 award gone to 8 scholars for their contribution in econometrics, which is the second highest among all branches of economics after macroeconomics. The most number of award has won by the macroeconomics. The second most number of award was won by econometrics. So such kind of impact is there for the subject on the on economics. Okay, so there are 6 volumes of handbooks on econometry have been published. Okay, and one more thing is that the second most number of Nobel Prize has been goes to the econometrics. Okay, it means that it has such kind of a impact on the mainstream economics. Okay, yes. Then as I told you, there is a journal Econometrica. This is one of the most a journal with the highest impact factor in the world in economics. Okay, so getting a publication in Econometrica journal is a big thing. I think only few Indian have got publication in the journal of Econometric. Okay, so this was started in 1930, 29 December. Okay, so most of the Nobel Prize winners, Nobel laureates are publishing in this journal of Econometrica, a journal that exclusively published econometric ideas. Okay, so what I'm trying to say that in the development of the subject econometrics, the Econometric Society published by Irving Fisher, Econometric Society formulated by Irving Fisher and Ragnar Fritz has played a very important role. Apart from that, Department of Applied Economics, Cambridge University and Cole Commission in US, they have also played their own role, but in different way. Okay, Department of Applied Economics, Cambridge University were provided certain tools to analyze the time series economics or time series data, whereas the Cole Commission has given certain models and concepts to discuss the simultaneity problem in economic model. Okay, yes. Then 6 volumes of handbook are published, and large number of award has gone to macroeconomics. Second highest was gone to the econometrics. Okay, and the development of the subject econometry has played a very important role in economic theory and economic research. Okay, I hope it is clear for you. Then this is the award gone to the econometrics, Nobel Prize, Nobel laureates in econometrics. Okay, the thing is that the first Nobel Prize in economics has gone to econometrics. That itself says it's important. Okay, we had a large number. The first Nobel Prize was established in 1969. Okay, in that year itself, Ragnar Fritz and Jan Tembergen, they have won the awards for developing applied dynamic model for the analysis of economic process. This is nothing but for developing certain tools in econometrics. Okay, so this itself says that how much important is there for econometrics in economics. Okay, after that in 1980, Lawrence Klein, then 1989 Thago Havelmo, 2000 James Heckman and McFadden, then 2003 Robert Engel and Granger. Okay, then one more thing is there, Christopher Sims, I think 2013 something. Okay, so he got the prize for macroeconomic idea, but his main contribution is in econometrics. Okay, so there are large number of Nobel Prize winners in econometrics, and their contribution is having a huge impact on the research in economics and verifying the economic theories. Okay, yes. So in the next class, I will discuss what are the uses and important of econometrics in economics. Okay, so till then, goodbye. Once again, welcome back to our lecture. In last two videos, we discussed certain basic concept about the subject econometrics, its subject matter, scope, and why we need such kind of a subject in economics. So today, what we are going to discuss is what is the methodology of econometrics. What we mean by methodology? Methodology is nothing but certain steps or stages that to be followed when we are doing certain econometrics experiment. When we do certain econometric investigation, we have to do certain step-by-step procedure. So what are that kind of steps? What are these steps that we are going to see in this lecture? Suppose the central government is proposing a reduction in income tax in order to boost the consumption. So before government proposing this kind of a policy changes, they have to do certain analysis. And suppose that you are hired by the central government to analyze what is the impact of this kind of a policy reduction on final consumption expenditure. So this is the task before us. What we will do, what are the steps we have to do, we have to follow. Okay, so all these steps together is known as the methodology of econometrics. Then basically we are having two different types of methodology. One is the classical methodology and another one is the Bayesian or modern econometric methodology. So what we are going to discuss in this portion is classical econometrics methodology. In this methodology, we have to go through 6 different stages or 6 different steps. First one, formulation of an economic theory or theoretical specification stage. In this stage, we have to specify our economic theory. As we have seen, econometrics is nothing but economics plus maths and statistics. Okay, so the first thing we have to do, we have to stick on or we have to focus is on economic theory. Okay, second one, specification of the mathematical model or specification of the model. Then third stage is the estimation stage. Fourth is evaluation stage, and fifth and sixth is the prediction and policy analysis. Okay, so all these 6 steps we will discuss in detail in this video. Okay, then we are coming to the first steps, theoretical formulation or theoretical hypothesis. Suppose what we want to learn in this, why we are hired by the government to study certain things. What is that? How a reduction in income tax and consumption expenditure are related. So we have to do that. We have to identify a proper theoretical framework that analyze this consumption and income pattern. As we know that, you might have learned in macroeconomics, there are large number of theories that are available in macroeconomics in order to describe certain consumption functions. Okay, then absolute income hypothesis there, then secular stagnation theory, life cycle hypothesis, permanent income hypothesis, and then Duesenberg is relative income hypothesis, then random walk hypothesis, then intertemporal choice theory. There are a large number of theories are there. What we have to do is we have to identify which theory is properly explain this situation. What is the situation? Government is going to reduce the tax. How it affect the consumption? Clear? Yes. So tax, if the government is reduce the tax, it will increase the disposable income. Okay, so on the one side we are having disposable income, another side is we are having consumption expenditure. Okay, so you just think about which theory analyze the relationship between disposable income and consumption expenditure. You can easily say that it is Keynesian consumption function. It is nothing but the consumption level of an individual or a household depends upon absolute current disposable income. Once again, consumption depends upon absolute current disposable income. Okay, what's absolute means? What is current? What is disposable income? Absolute current disposable income. It is nothing but income minus your personal tax. Okay, that is available on a current period without comparing into any others. That means absolute, not relative. Current, not past or future income. Then disposable income, income minus personal tax. Okay, so he explained that consumption is linearly and non-proportionately related to disposable income. That we will explain later. Okay, then in order to explain this theory, he has put forward some ideas. Okay, then Gregory Mankiw called these ideas, or he categorized all these ideas into three conjectures. First one is the income is the only determinant of consumption, and interest rate doesn't have any role to play in determining consumption. Why he has made such kind of a conjecture? Have you ever think about it? Yes. Because before Keynes there was classicals. Okay, what they opine or what their idea about consumption is, consumption could be affected by the interest rate. If the interest rate is very high, then people will reduce their consumption and they have a tendency to save more. And due to this fact, there may be certain negative relation between interest rate and consumption. This was some idea which were given by the classicals. Okay, so the Keynes attacked this notion, and Keynes said that no, it is not like that. Interest rate doesn't have any role to play in determining one's consumption. It is only the income determining the consumption. Which income? Current disposable income. Clear? Yes. And second conjecture is, whenever income increases, APC will down. What does it mean? What is APC? APC is nothing but C by Y, consumption divided by Y. Okay, so it is always going down when income increases. It means that whenever your income increases, consumption will also increases, but the consumption will not increase at a rate that the income increases, always less than that of that. Okay, for example, if you suppose that your income is 100 rupees, your consumption now is 90 rupees, you are saving 10 rupees now, your income increased to 200 rupees, your consumption should not increase to 180. That is a proportionate increase. Okay, below 180, that will be non-proportional. That means your consumption may increase to 170. Okay, it should not be 180 and 180 above. Okay, and you will save more. When your income increases, you will reduce your consumption and you will start to save more. Because of this fact, APC will always down when your income increases. Clear? This is the second conjecture. Third one, MPC. MPC is nothing but changes in consumption due to changes in income. This is always lies in between 0 and 1. Okay, why he has made such kind of an assumption? Because if the value of MPC is going beyond 1, What does it mean? If a person income is 100 rupees and if it is increased to 200 rupees, then if MPC is beyond 1, then his consumption will increase more than 200. Okay, more than proportionate. Okay, so that will never happen. Okay, so this was the main idea of the Keynesian consumption functions. Okay, so this we have to specify. So we are analyzing whether the tax rate decrease, the proposed tax rate decrease, how it will affect the consumption pattern. We are going to analyze this problem using Keynesian consumption function. Okay, so we are saying that consumption depends on income. Our consumption depends on current disposable income. This is our theoretical model, or this is our hypothesis. This we are going to check. Okay, so this is the first stage, the stages of theoretical formulation. And then second stage, coming to the model specification. So all these three conjectures which I have given can be explained either through a graphical, either through graph or through a algebraic model. So what is an economic model? Economic model is nothing but a simplified representation of a real world or real economic phenomenon. We are going to simplify a big fact into certain numbers, or we are analyzing, or we are transferring or converting that big idea into a graph. Okay, this idea is known as economic model. Economic model is nothing but simplifying the real economic phenomena or real world economic phenomena. How to simplify? Either we can adopt graphical representation, or we can do certain mathematical specifications or mathematical equation. Okay, so how we can convert the three conjectures into a graph? Look at this graph. On the vertical side, we are having consumptions. Horizontal side, we are having income. Okay, so whenever income increases, you can see that consumption is increasing. Okay, and here why we are having why our graph is starting from the mid, almost above the zero, or about the origin of the graph? Because of the idea given by the Keynes, that is the autonomous consumption. Okay, that means even if a person is not having an income, he has to consume. Okay, so how much he will consume, that amount is known as autonomous consumption. Okay, that's why you just check the in the zero itself our graph is starting. Okay, but certain above. Okay, this means that the area of in between origin and the alpha written in graph, this is the amount of autonomous consumption. Okay, yes. Then the graph, you can see that it is not starting from the origin, it is starting from the almost the middle. Okay, or above the origin. Why it is so? Because we assume that less than proportionately. Okay, if it is proportional, then it will start from the origin and the slope will be always equal to 1. But here the slope is always less than 1 and above the 0. Okay, that means it shows that MPC. Okay, so using this graph we can measure MPC as well as autonomous consumption. Clear? Yes. Then an economic model in the form of an algebraic or a mathematical equation help us to describe relationships and a series of other behaviors associated with this relation. Let me take an example. Okay, as we know that the quantity demand for a commodity depends on many factors. Okay, so when we describe such kind of factors, it will take a lot of time, it will consume more space. Okay, so how we can simplify that one? We can simplify that by using a mathematical equation. Okay, so let me take an example. Okay, as we know that the quantity demand for a commodity depends on many factors. Okay, so when we describe such kind of factors, it will take a lot of time, it will consume more space. Okay, so how we can simplify that one? We You convert that statement into an equation. QD is equal to function of P, price, then price of related commodity, income of the consumer, taste and preference. Using 5 letters and some notations, mathematical notation, we can describe a series of behavior associated with the demand. That is the advantages of economic model giving to us. Okay? Yes. And one more thing I would like to say, that if there is a non-mathematical equation that linking the relationship in the theory, such kind of theory we cannot empirically verify. Okay, so in order to empirically verify a relationship or theory, there should be a mathematical equation, or there should be a mathematical expression. If there is no mathematical expression, then we cannot study scientifically using data or using econometrics. Okay, yes. Then you tell me, what is the form of the function? You look at this graph. What is the form of this graph? Is it constant function, straight function, or linear function, quadratic, cubic, or exponential function, or logarithmic function? What kind of function is this? It is, we can say it's a linear functions. Okay, so linear function is nothing but a function in which the parameters or the variables will be appeared with power 1. Okay, that means if we have a straight line other than horizontal or vertical, then it would be a linear function. Okay, if it is a straight line or horizontal line, it is a constant function. Okay, so here we can see it is a linear function. Okay, that's why we are saying that Keynesian consumption function is a linear and non-proportional. If it is linear and proportional, then it would have started from 0 itself. Okay, but just not like that. Okay, so we are deriving the functional form of this model, okay, from our theory. Theory says that it is linearly related. Okay, so we know that the equation or the graph would be, or the equation will be a straight line equation or a linear equations. Okay, yes. So what kind of, suppose if you are estimate the cost function, what will be the function? Cost function U-shaped. Okay, so if we want to get a U-shaped, what will be the function? Quadratic. If we have an inverted U-shape, Kuznets curve, if you want to verify the Kuznets curve, what would be the function? Inverted U? Yes, quadratic function. If you want to verify the total cost curve or the total variable cost curve, it is a reverse S shape. Clear? Then the graph will be, or the function would be cubic function. Okay, if you want to verify a horizontal line like perfectly elastic or perfectly inelastic, then it would be a constant function. Clear? Yes. So what kind of a function we have to use is depends on what our theory says or what we can introspect from the theoretical or from the common sense. Okay? Yes. So this is the mathematical or model specification stage. Okay? So once we have a pure graphical analysis or pure graph, from the graph itself we can derive a mathematical model. Okay, look at the first graph that we analyzed. Okay, after that you can see that y is equal to function of x. Okay, y is our dependent variable, x is our independent variable. We will discuss later, okay, what is this dependent and independent. It says that y means consumption expenditure is depends on income. Okay, yes. Then on the next side, next line, we can see that y is equal to a plus bx or a alpha plus beta x. Okay, in the above, y is a function of x. It means that consumption expenditure depends on income. Then why we are having the straight line equation? Why we are not? Why don't we need this functional form? Why we converted this functional form into a linear equation? Because the functional equation will just tell you whether these variables are related or not. It won't give us what is the direction of the relationship. Okay, suppose if I am the next line, if I am writing Q is a function of P, here Y is a function of X. Consumption depends on income, quantity depends on price. Both are giving the same notations, and when we look at both equations, both are looking same, but both are having the different meaning. Okay, Q and price are negatively related, consumption and income are positively related. So this kind of a direction we cannot get when we look at the functional form. That's why we are converting the functional form into a appropriate functional form. Okay, so the next we have converted this form into y is equal to alpha plus beta x. Okay, so this tells us y is consumption means an intercept, that is called autonomous consumption. Okay, what will be the consumption expenditure when our income is equal to 0? Then plus, this plus means that y and x are positively related. Into what extent? That is given by the beta coefficient. Okay, so the beta coefficient give us on what extent this, or how many percentage this y and x are related. Okay, that means if income increased by 100%, how much consumption will be increased? This would be given by this beta coefficient, or what we call theoretically marginal propensity to consume. Okay, yes. Then now we have specified a mathematical equation, y is equal to alpha plus beta x. Clear? Yes. But there's a problem here. What's the problem? The mathematical model assumes an exact or deterministic or functional relationship, whereas most of the economic relationships are inexact or statistical or stochastic. Deterministic versus stochastic, exact versus inexact, functional versus statistic. What does this mean? That it means that our mathematical model assumes that consumption will be only depends on income. Consumption will only depends on income. That's why I call it as a deterministic only. There are no any other factor that will affect the consumption. Okay, but the problem is that in economics we cannot have such kind of a relationships. Okay, we cannot exactly tell a relationship because we are dealing with humans, not with laboratory experiment. Okay, so the deterministic relationship we can have in pure natural sciences, but in social science we cannot have a deterministic relationship or exact relationship. In always the economic relationship are inexact or what we call as stochastic. Okay, yes, let me tell you in more detail. Look at, can you suggest any other determinants of consumption other than income? In mathematical model we assume that the consumption is the only determinant of the income is the only determinant of consumptions. Okay, can you suggest me any other variable other than this income that will affect the consumption? Yes, lots of variables are there. Size of the family will affect, the wealth of the family will affect. Okay, the how many number of people are employed, unemployed. Okay, how many persons are there in this household, how many members are there, what's the size of the family. Okay, where this house or household is located, is it in urban location or a rural locations? All these would affect whether this person is married or not. All these will affect the consumption pattern. Okay, so in mathematical model we assume that consumption income is the only factor, but in reality not only the income, there are large number of other factors. Okay, then there are certain factors that we cannot reasonably observe or measure. Meaning, there are certain factors that even we cannot measure. You just take the wealth. Everyone knows that the wealth will be, the consumption will be affected by the wealth. If those who are having higher wealth will consume more. Okay, but tell me how to measure the wealth. On the base of wealth, on the base of land. If it is on the base of land, which land? Okay, how to price the land or how to evaluate the land? Okay, then on the base of gold ornaments, on the basis of houses or gadgets used, on the basis of house, the size of the house, on the what basis, on the basis of the investment in financial markets. So we can measure the wealth in different way. How to measure it? There is a problem. Okay, and there are some other variables that affect our consumption, but that we cannot even list. For example, I have given you 500 rupees each to everyone. Then me and you went to a restaurant and I told you to buy whatever you want to buy. I have given you 500 rupees, it is your income. You are going to consume using this income. Okay? Will you consume in the same way as others? That means there's a juice in that shop. All of you will order the juice? No. If all of you are ordering the juice, then your behavior is exact, deterministic. But we are all human beings. We cannot have same taste and preference. Some people may order tea or coffee or Horlicks or Boost. Some may be juice, cake. Okay, this means that human behaviors that we cannot forecast or that we cannot predict using a mathematical model, because mathematical model assume that your consumption is only depends on your income. Okay, but it is not income. There are some other factors, and there are some factors that we cannot list out. Okay, then why you are having different tastes that we cannot list as a variable. Okay, so we are having three problems here. One is there are some other factors that we are not including in this equation. Okay, that may affect our consumption. Second one, there are some variables that we cannot measure properly. Third one, there are certain variables that will affect our consumption, but we cannot list out. Okay, but as we know that all these variables will have an effect on our consumption, so we have to account all these effect. Okay, so what we do? Here comes the econometric model. Econometric model is an answer for this question. What is that? Econometrician would modify our equation or our deterministic model simply adding a variable into that. What is that variable? It is called the U term. Okay, so we are just converting a mathematical model into an econometric model, simply adding a term or a variable called U term or disturbance term or error term. There are different names for that. If you look at different books, you can see different names. Okay, disturbance term, error term, these are the most common word. Okay, U term or epsilon term. Okay, then what this U will capture? U is a random variable which represent all other omitted factors from the equations, errors in measurement of the variables, and other factors that affect our consumption, but we are not explicitly including in our equation. We have included only income, y is equal to a plus b xu or alpha plus beta xu. Here we have included only one variable, income. There are other variables. Size of the family we are not including. Where these fellows are locating we are not including. How many members of the families are there we are not including. We are omitting all these variables and putting one term called u. There are wealth, but we cannot measure it. So what we are doing, we are putting a variable u. There are certain variables that even we cannot say, that also we are putting, that also we are capturing by u. Okay, so u is a random variable that will capture all other variables that are omitted from our models. Okay, but that will have a impact on your consumption. Okay, so this u will capture all other omitted variable from your models. Okay, and what will be the impact of all other omitted variables from this models, that will capture by this u term. I hope it is understood. Okay, and dealing with this error term is the most important exercise in econometric analysis. So from this onwards we are dealing with how to deal these error terms. What is the error term is, what are the things the error term will capture, how to measure these error terms. Okay, what are the assumptions related to these error terms. Okay, and what will happen if certain assumption about this u is violated. These are all is the subject matter of econometrics more specifically. Okay, yes. Then apart from u, you can see an alpha and beta in this. What is that? It is the parameters. Okay, so we will discuss these parameters later, and you can see I am putting a alpha and beta. In some books they have put AB or A1 or B1 or B2, something like that. Don't confuse with that. It is simply a letter. You can put AB, you can put any number, any Greek or any Latin or whatever the letter you want, you can put it. Okay, yes, but it's a purely a letter to denote a parameter. Okay, so alpha is a parameter or what we call intercept. Okay, then beta is another parameter that's called a slope parameter. Clear? Yes. So this is the econometric specifications. Okay, so we discussed theoretical formulation, then we discussed specification of the model. In specification of the model we first discussed mathematical specifications and the problem with the mathematical specification, then why we need a econometric specification, then how to modify a mathematical equation into a more econometric specifications, and what is u, what are the things this u will capture. Okay, I hope it's clear now. Yes. Then we will discuss what is this third stage, the estimation stage. Two stages are over, two steps are over, then we are moving to the next step, estimation stage. Okay, so in order to estimate certain things, what we need first, we need to have a data. Okay, without data we cannot estimate. We are having a theory, we are having a model, but we don't have a data. We cannot estimate it, we cannot verify it. So we need data. Okay, what a data is. Okay, you look at this graph, you look at this screen, you can see I am collecting the data from 5 households. Their consumption is given, their income level is given. You check the first household. One is the first household. Their income is 300 rupees. They are consuming only 220 rupees. Remaining 80 rupees they are saving. Okay. So in this graph, there are 3 different elements or 3 different concepts are underlying in this graph. The first one is the element. What is an element? An element is a specific subject or object about which the information is collected. We are collecting the information from household. So this household is the element. Clear? Yes. Then a variable is there. What is a variable? A variable is a characteristics under study that assumes different values for different elements. So we are not studying about the household. We are studying about what is the consumption and income pattern. So consumption is one variable, income is another variable. Clear? Yes. And this variable assume different values for different elements. You will have a different values for different elements. Okay. Then what is an observation? A value of a variable is an observation. 220 is an observation. 220 300 is an observation. Okay. Yes. So the next thing you have to understand that what's the data. A series of observation is known as data. Okay. A series of data for one variable or two variables is known as data. Okay. I hope that's you understood what a data is. Clear? Yes. So in econometrics or in reality, there are two types of data. One is the experimental data and the another one is the non-experimental data. What is the difference between experimental data and non-experimental data? Experimental data means the data collected or generated in laboratory environment in the natural science. So in science, in purely natural or environmental science, they are making or they are converting or generating certain variables using some laboratory experiments. Okay, this is the experiment data. The one of the most advantage thing is that these data are purely quantitative and they can manipulate the variable and its measurement. Okay, once a variable that is created in a laboratory experiment, that they can manipulate it and it's purely quantitative. Okay, so most of the natural science data are experimental data. The data has been generated using from a laboratory experiment. Okay, but not experimental data are the data accumulated or generated or collected from individual firms or different segments of the society. Okay, so not experimental data are the data accumulated through a controlled experiment on individual firms or segment of the society or economy, or these are the observational data. Okay, this means that we are reporting actual happenings. Suppose how many persons are there in a family? This is our question. We are going to collect the data. How many persons are there? There are 10 persons. We can only report 10. We cannot manipulate it. Okay, but in using certain instruments in chemistry, by adding certain things in, I don't know whether what to say, so they can generate certain things. Okay, and by adding certain other things, they can convert the same thing into different levels. Okay, so by adding or by doing certain experiment, they can convert their data. But in social science, we can only report the data and we cannot manipulate the data. Okay, so the most of the economic and social science data are non-experimental data, or what we call observational data. Okay, but nowadays, as you know, that there is a branch of experimental economics or behavioral economics. Okay, so in behavioral economics, they are generating certain data. Okay, that means suppose we want to measure how education and poverty are related. What they have to know, they will identify certain pupils who are in poverty or who are suffering from poverty, and they will give them educations, and they will wait for 10 or 15 years what happened to that fellows. Okay, then after 15 years they evaluate what happened to their poverty. This is some kind of an experimental approach to social science data. Okay, but nowadays most of the data are experimental data are generated by the science or purely natural science people, but nowadays the economics also entered into the field of non-experimental data, especially in behavioral economics. Clear? But other than this behavioral economics, almost all the data in economics are observational data. We cannot manipulate the data. We can only report what actual data says. Clear? Yes. Then we are having, what is the structure of the data? Okay, so we have decided, we have find out the theory, we specified the mathematical model, econometric models. Then we decided to go to data, to collect the data. We decided to go to non-experimental or observational data. Okay, yes. Then what would be the structure of our data? This is the next question. What would be the structure of our data? In economics, we are having 4 varieties of data. Okay, they are cross-sectional data, time series data, pooled cross-sectional data, and panel or longitudinal data. There are 4 types of data in econometrics: cross-sectional, time series, then pooled cross-sections, and last one is longitudinal data, or what we call panel data. Okay, so what is a cross-section data? A data collected is a single dimensional data collected at a point of time from individual, household, firms, cities, states, countries, or varieties of other units taken at a given point of time. Okay, so the data collected at a point of time. What is this at a point of time? Okay, for example, several families may be surveyed during different weeks within a year. Suppose if we want to study, we want to get the data about consumption and income of different families, but we took almost 1 year to complete the data collections. Okay, but still it is cross-section, because here we don't have a time element in our analysis. We are having cross-sectional units, not a time element. Okay, so in cross-section unit we don't have a time element. We are collecting the data at a point of time from different units. Okay, these different units are known as cross sections. Okay, so even if a survey took 1 year, all these 1 year will be taken as a one time, okay, not the several time. Okay, so you look at this. You look at the cross-section data are obtained using a random sample. Okay, so you have to understand that the cross-section data are collected or can be collected, or if a data is a cross-section data, then we have to understand that that data is collected through a random sampling techniques. Okay, that means if we have obtained 500 data from household, 500 household data we have collected in our area where there are more than 1000 or 2000 household others. So this 500 sample is collected through a random samplings. Okay, so this is the one of the crucial assumption of cross-section data. Okay, and one of the main feature of this data is that the order of the data, it doesn't matter. That we have to understand that. Okay, that means if I collected the data or the data from household which is very nearest to me, and the last one I have collected from somewhere else. Okay, so this type of an ordering will not affect you in your analysis. Okay, so if you collected some data in the first, if you put some data in the first and some data in the last, it won't change the result. Okay, so suppose in a class there are 500, there are boys and girls. Okay, there are from different backgrounds. Okay, if I took girls first then boys, or first boys then girls, it won't change the result, because whatever the order you may put, it won't change the result. Okay, so once again I am repeating, cross-section data is the data, single dimensional data, means there is no time dimension, single dimensional data collected at a point of time. Clear? Then the cross-section may be the individual, household, firm, industry, state, different countries, or different any other units. Okay, then when we say that there is no time dimension, it means that even if we took many years to complete a data collection, still all such kind of data is considered as a one unit. Okay, then all these cross-section data should be randomly collected. Order doesn't matter. Okay, then this kind of a data are extensively used, especially in applied microeconomic fields such as labor economics, state and local public finance, industrial organizations, urban economics, demography, health economics, or industrial economics. Okay, so these cross-section data are we regularly use this kind of cross-section data in applied microeconomic field. Clear? Yes. And in order to how we can understand what type of data a researcher has used, look at in the variables. After variable, if there is a subscript called I, then we have to understand that these techniques or this estimation has been done using cross-section data. Okay, so cross-section data is usually denoted by the subscript I. Okay, yes. So how would be the data look like? Look at the first example, 1 2 3 4 5 6, income, expenditure. Okay, so income is one variable, expenditure is another variable, household 1 2 3 4 5, first household, second household, third and fifth household. Okay, then if you put first household last household first, the result won't change. Clear? Yes. So first, second, third, fourth, fifth, this is our cross section. This next two columns are the data. Okay, look at the next one. Here we are collecting the data from labors. So in the first case it is from household, so household is the cross section. The next session we are collecting the data from labors, labor wage, education, experience, their gender, their marital status. So 1 2 3 4 5, what does mean by 1 2 3 4 5 here? It is first labor, second labor, third labor and fifth labor. Clear? Okay, so here we don't have a time dimension. Okay, so this will be more clear when we discuss the time series. What is time series? Time series is a two-dimensional data. Okay, or data collected for the same variable in different period of time. We are collecting the data for a variable but in different period of time. Okay, so this period may be decennial, annual, 6 month, biannual, quarterly, monthly, weekly, or fortnightly, hourly, secondly, whatever may be the time, no problem. Okay, but here we are collecting the data on the same entity or same variable in different period of time. Okay, to look at the case GDP. What is GDP? Gross domestic product. Okay, is a variable. Okay, how if you have seen the GDP data, how it look like from 1950 onwards, 1951 we have a GDP figure, 1952 another GDP figure, up to 2019 we have a GDP. Okay, so we are having only one variable called GDP, but for a GDP we are having different values at different period. Okay, earlier we are having the data on different cross sections. household 1, household 2. Here first year one data, second year another data, third year another data. Okay, here the time is changing. The earlier section where the unit changed or the household changed. Okay, so here we are having a time dimension. The data are chronologically ordered. That's why the ordering is very much important. Okay, we cannot write 1951 this much GDP, then 2001. We cannot say like that. There should have a GDP. There should have a proper ordering, chronological ordering. Okay, and cross section we denoted I, whereas time series we usually denoted by T. So XT, YT means what? Y data collected at a particular time period. So we have to understand that it is a time series data. Clear? Yes. And when we discuss the time series data, we have to take care of lots of other things. Different problems will be encountered like seasonality, stationarity, all such things. Okay, so it is not easy to analyze a time series data when we compare to the cross section data. Okay, that we will learn. Okay, look at the data. Year 1951, 52, 53 up to 2019. Look at M3 money supply, GDP at factor cost. Okay, so we are having two variables, M3 and GDP. This same data has been recorded in different period of time. Okay, so this is what we call time series data. Okay, the next thing is pooled cross sections. Cross section is pooled. What does it mean? The data with both cross sectional and time series features. Here in this data we are having the feature of both cross section and time series. For example, you might be aware about NSSO's round conference or round surveys. Okay, so there are two surveys, 65 round survey and 66 round survey. What the NSSO is doing in these surveys? They are taking certain samples and they are surveying the sample for variables such as income, saving, family size and so on. Okay, so in 65th round data, they have collected the data 10,000 data from different states on different variable like income, saving, family size and so on. In 66, what they are doing? They will do the same analysis, but the unit may be different. Okay, suppose in the last 65th round they have collected the data from me, but in 66 they may not collect the data from me. Okay, they will have another samples. Okay, even though questions and survey methods and questionnaire are same, they will collect the data in different period from different cross sections. Okay, so here we are having two time. 65th is maybe in 2005, 26th 2010, the 5 years gap. Okay, then cross section is also different. They have in the earlier time they have collected the data from some peoples, and this time they are collecting data from another. Okay, yes. So in this we are pooling the cross section for different years. Okay, and this pooled cross section can also be analyzed using some standard cross-section unit, cross-section econometric methodology, but there are certain problems when we deal this kind of a data that we will analyze later. Okay, so how this data look like? You can check this table. We are having 500 data, 1 2 3 4 5 up to 500 data. Okay, but look, 1 2 3, these 1 2 3 data are collected in 1 year 1993. 1993 first household, 1993 second household, 1993 third household. Okay, up to we have collected 250 data from 250 household in 1993. Okay, So we are having 1 year 1993. For 1993 we are having 250 household. Next 1995 another year. In 1993 there are another 250 people. In total we are having 500 data in 2 different periods. Okay, so this type of data is known as pooled cross-section data. Clear? Yes. So there are one more thing is there. There is a small difference. This is most confusing thing when we look at the different data. Panel data or longitudinal data. Okay, so a panel data consists of a time series for each cross-section unit in the data set. We are having time series for each cross-sectional unit in the data set. Okay, for example, wage, education and employment data for a set of individual followed over a 10-year of period. Okay, or you just take the GSDP, gross state domestic product, which is a state GDP. Okay, then we are having annual GDP data, time series annual GDP data for 1951 onwards for different states. Kerala, Tamil Nadu, Karnataka, these are all cross sections. 1951, 52, 53, all time series. Okay, so here we are having time series on the one side and other side we are having cross sections. Okay, so this is also what? A combination of time series and cross section data. Okay, so you may have a doubt, what is the difference between a time series and a cross section data? Okay, so I will clarify that doubt first. In pool data, the observation in each cross section do not necessarily refer to the same unit. It means that in each period the sample may be different. Okay, the samples are independent. That means in the last time they may have collected data from a household. This period it is not necessary to collect the data from that household. The house may be different. Time may be differ, house may also differ. Clear? Yes. So NSS survey is just like a pooled cross-section data. Whereas in panel data, the same cross-sectional units observed necessarily refers to the same unit. Okay, just like our population census. Okay, so population census is conducting every 10 years is conducting. Okay, so we will have a population data for different states at different period of time. Okay, here the states are same. Kerala, Tamil Nadu, all the same, but only the years are changing. Okay, but in the pooled cross section both year and cross section will change. But in panel data only the time will change, cross section will remain unchanged. Clear? Yes. So in both these, since there is an element of time in both pooled cross section and panel data, there will be a time element. Clear? Yes. Then after we decided to go with cross section. We will discuss cross section first and then we will come to the time series. Okay, so most of the time series part we will discuss in the first semester or when we discuss the time series analysis or advanced econometrics. So in the basic econometric course we are mainly dealing with cross section data. Okay, so we decided to go with cross section data and we have decided to collect the data from household about consumption and income. Clear? Then what is next? Estimation. We have to do estimation. How to do estimation? What is estimation? Estimation is nothing but we are having an equation, econometric equation, where alpha, beta are parameter. Okay, find out a numerical value for this alpha and beta is known as estimation. Clear? How to find out the value for alpha and beta? If we get the value for alpha, it is consumption, sorry, autonomous consumption. If we get the value for beta, it is known as MPC. Okay, so getting the value for autonomous consumption and MPC is the estimation procedure. How to get the value? Large number of methods are available. OLS method is one method, regression method. Then maximal likelihood is another method. Okay, then moment based method is another method. So there are large number of different econometric methods are available. But in basic econometric course, we will only deal with OLS, or what we call regression technique. Okay, so we are having an equation y is equal to alpha plus beta x plus u. We have to find out alpha and beta. Okay, then if beta coefficient, or if the value for beta lies in between 0 and 1, if the numerical coefficient of beta is 0.5, then we can say that Keynesian idea about consumption function is right. Okay, so if we got 0.9, then we can say that Keynes is right. How to do this? That we will check. How to do a regression analysis? That we will check. Okay, so I am doing this exercise with a view to, or with an understanding that you all study the basic regression techniques in your undergraduate programs. Okay, yes. So we will discuss the technique of regression later, but for just for introduction purpose, or for just introducing the estimation technique, I am giving this. Okay, so y, x, we are having consumption data, we are having income data. 1, 2, 3, 4, 5. Only 5 household is there. Okay, the first step is you find out the value for, find out the average consumption and average income. So you can see the in the slide, y bar is equal to 65, x bar is equal to 76. Okay, it means that y is consumption, average consumption is 65, average income is 76. Okay, then you have to find out the deviated y and deviated x, or small y and small x. Small y and small x means nothing but the deviation from the average. Okay, y minus y bar. Look at minus 10. Okay, y bar is 65, y is actual y is 55. 55 minus 65 is equal to minus 10. We can calculate all that. Then small x means actual x minus x bar. Actual x is, the first value is 60, 76 the x bar, so we will get minus 16. Okay, then you multiply the small y and small x, yx, 10 into minus 16, minus 10 into minus 16, 160. You get 160, 45, 0, 40, 180. Total is 425. Then you find out the small x square. Small x means your independent variable. Okay, it's square. So small x means 16. 16 square 256. Okay, then 256, 81, 165 and 324. You will get 726. Okay, so regression equations, we are having a regression equation. It is just nothing but beta value is sigma xy divided by sigma x square. Okay, how to get this sigma xy, sigma x square, that all we will discuss later, and we will derive this equation. Okay, so don't worry about it. Okay, so we got 425 divided by 726, 0.58. What is this? 0.58 is our MPC. Okay, so what is alpha? Alpha means y bar minus your estimated beta value into your x bar. So 65 minus 0.5853 into 76. Okay, so we have got 20.50. So we have estimated the model. How the model will look like? Y cap. or y hat. It means that we are estimated this model y hat 20.5 plus 0.58 x. Clear? Yes. So now we have estimated this model. Okay. So this is the estimation procedure using the regression analysis. The how we got this equation and all that we will discuss in the second module. Okay. Yes. So look at here. Our intercept is 20.5 and MPC is 0.58. How we can interpret it? First case, even if a person in these 5 members don't have an income, they have to they need minimum 20 rupees for their necessary purpose or unavoidable purpose. Okay, so they, in order to live in this area, they need at least 20.5 rupees. That is the autonomous consumption. Okay, then MPC is 0.58. What does it mean? If a person's income is increased by 100, their consumption is increased by 58 rupee only. The remaining amount they will change, they will saved. Okay, so if a person is income increased by 5,000 rupees, their consumption will be increased by 585 rupees, 585 rupees. Okay, so using this we can say one thing, that whatever Keynes said about MPC is right for this 5 individuals. What Keynes said, MPC is always lies between 0 and 1. So this is correct. Clear? Yes. So here now we have empirically proved that Keynes is right. Clear? Yes. And after this, we have got a value for MPC and intercept, but still we cannot believe this, because in statistics there are certain reliability tests. Okay, so we need to do certain precision or reliability test, and if all the test says that your result is fine, then only we can move. Okay, or sometime you have got this information, or you have got this MPC and alpha because of some measurement error or some sampling errors. Okay, so all that thing we have to check. So this is the evaluation stage. After the estimation stage, we have to go to evaluation. Okay, how to evaluate? You have to check whether your estimator is least. You have to check whether your R square is highest or not. You have to check whether your standard error or variance is low or not. You have to check whether your t statistic is close to 2 or not. You have to check whether your variable is efficient or unbiased, or whether it has a minimum mean square error or consistent. Okay, so you have to check all these criteria. Okay, all these criteria we will discuss later in detail. Okay. So then after evaluations, you might have learned the hypothesis testing in your advanced statistical course. Okay, so you have to test the hypothesis. Okay, so in our model, what would be the hypothesis? Income has no effect on consumption. The first assumptions, income has no effect on consumption. Okay, so similarly you can create as much as hypothesis you want to analyze or you want to get, and using the data and the result you can analyze the result, or you can find out whether your hypothesis is true or not using large varieties of tests, others z test, t test, f, chi-square. Okay, all these tests are we have to use on a particular situation. Okay, we have to understand what type of statistics we have to use in this particular situation that we have to use, and we have to check whether our hypothesis is true or not. Clear? Yes. Then after this, we are going to the 5th stage, forecasting. So one of the most important use of estimation technique is to forecast. Okay, forecasting means nothing but to forecast or predict the future values of an economic variables. Okay, so we are having a large number of different forecasting tools. The regression techniques or OLS technique is one of the classical forecasting tools. Okay, so look at this table: 55, 60, 65, 70, 75. There is one more fellow is there. He is not claiming his consumption, but we know his income. Then don't worry, don't go to him, don't ask him again. You get his income, you predict his income using the available informations that we can do. Okay, because we have got 20.50 is the intercept, 0.58 is the MPC, then you multiply his income, you know his income is 100 rupees, then probably his average consumption would be 78.5. Okay, so after the estimation we have to do, if we need to do forecasting or prediction, we have to do that. Okay, yes. Then the last stage, policy purpose. So why we hired by the government? To do a policy analysis. What's the policy analysis? Whether this tax reduction will increase the consumption of the people or not. If it is increasing, the how many percentage? Clear? Yes. As we know that the tax reduction will increase the current income, it will increase the expenditure by the amount of multiplier. Okay, you might have learned this government purchase multiplier and tax multiplier. I hope it is you are all read at least the Gregory Mankiw macroeconomics. Okay, basic ISLM part. Okay, in that he defined the multiplier. What is multiplier? 1 divided by 1 minus MPC. Okay, so whenever there's a increases in the government expenditure or a decreases in the tax, it will increase the consumption expenditure by the amount of multiplier. Okay, so multiplier means 1 divided by 1 minus MPC. So 1 divided by 1 minus, what's our MPC? 0.58. So it is 2.38. Okay, so we got the result. Okay, this is the duty of an econometrician. Then we have to suggest to government that if you increase the amount by this much, the consumption of the people would be increased by this 2.38%. Okay, so this is we have got from just analyzing 5 peoples. Okay, so by adding more people into our analysis, we can increase the stability and the reliability of this estimator. Clear? Yes. Then after this you can do whatever the suggestion they want. Okay, you can analyze it. Okay, so this is the 4 steps or 6 steps that has to be followed when we are doing an econometric analysis. Starting, we need an economic theory. We have to specify, we have to formulate an economic theory. Okay, then we have to specify a mathematical model. There are problem with mathematical model, so we need to do econometric modeling. Okay, then we have to do an estimation. In estimation, the first step is data collections. Okay, then after hypothesis testings, then if our hypothesis testing is wrong, then you have to revise your data again, you have to estimate the models again, you have to do evaluations. Okay, so if your model is good, then you have to forecast, and finally you can apply this forecaster tool to in policy purpose or policy suggestions. Okay, so this is all about the classical econometric methodology. I hope the session would be helpful to you. Okay, please read the book. You can refer some book. Hi, hello my dear friends. So in last many videos we discussed about the subject matter of econometrics, what the subject is all about. Today we are just coming inside of the subject, and we are going to discuss one of the cornerstone of econometrics called the regression analysis or regression technique. Okay, so the regression technique was first coined by, or the term regression was first introduced by the Francis Galton. Okay, so Francis Galton was basically a biostatistician. Okay, so he analyzed how the parents' height and their children's heights are related. Okay, then he found that in his article Family Likeness in Stature, he pointed out that there is a tendency for tall parents to have tall children and short parents to have short children, but the average height of children born from parents of a given height tended to move or tended to regress towards the average height of the population as a whole. Okay, so he found that in his analysis he found that tall parents is having tall children. Okay, short parents is having short children. But if we take certain children from a given height of parents, their heights and the average population heights will be almost same. Okay, so this was his idea, and this idea was rechecked by Carl Pearson, and in his book or in his article The Law of Inheritance, okay, he found or he confirmed or verified this law. Okay, so what this Carl Pearson said, that the average height of a group of tall parents, okay, average height of sons of a group of tall fathers are less than their father's height, whereas the average height of a sons of a group of short fathers are greater than their father's height. But regressing the tall and short sons like towards the average height of the all men. Okay, so this says that if we take the average height of children or sons of a tall parents, we find that the parents is having more height than the children. Okay, but if you take the short parents, the children is having more height than the parents in the case of short parents. Okay, but if we take a group of sons, a group of children's, okay, so it will also regress toward the height of the all persons in the or all men in the total populations. Okay, so this was the idea about the origin of the idea of the regressions. Okay, so the idea of the regression was first propounded by Francis Galton, even though he has not popularized it. Okay, and it was again reconfirmed, or the idea of the Francis Galton was confirmed by Carl Pearson. Okay, so what I am going to tell you in this video or in this slide is the term regression was first used for analyzing the relationship between the height of a group of parents and their child and their sons or daughters or their children. Okay, yes, but nowadays the regressions are not only used in this biostatistics, okay, but it is used in almost all the branches of sciences. Okay, and the modern interpretation of the regression is not like its older interpretations. The regression technique has been substantially improved over a period of time, and now we are having a modern interpretation of regressions. Okay, so what does this modern interpretation says? This says that the regression is a technique, okay, concerned with the study of dependence of one variable on one or more other variable called independent variable or explanatory variables, okay, with a view to estimate or predict the population mean or population average of the dependent variables in terms of the non and fixed values of the independent variables. Okay, so here we are having two variables, dependent variable and independent variables. Okay, look at the definition. dependence of one variable on one or more other variables. So there will be only one dependent variable, and there may be more than one independent variable. Okay, so there will be only one dependent variable, and there is a possibility of having more independent variable. Okay, so why we are studying this dependence? In order to estimate, okay, or in order to predict the value of the dependent variables in terms of the value of the independent variable. So we are going to find out if we know the dependent variable values, if we know the numerical values of the dependent variables, but we don't know about the dependent variables. Okay, so from the independent variables we can find out, or we can estimate or predict the value of the dependent variable. Okay, so once again I am repeating the idea, or the regression analysis is concerned with dependence of one variable on one or more other variables. Okay, with a view to estimate or predict the value of the former. Means what? Former means dependent variable, later means independent variable. Okay, for estimating the average value of the dependent variable in terms of the non values of the independent variables. So this was the main idea or the modern interpretation of the regression analysis. Okay, so let me take an example, a small example now. The detailed example we will see later. Okay, consumption is a function of income and wealth. Consumption is a function of income. If there is income alone, then consumption will be our dependent variable, income will be our independent variable. So here regression analysis is concerned with only one dependent variable and one independent variables. Okay, but there is a possibility of having more independent variables. So we are saying that dependence of one variable on one or more variables. Okay, then with a view to estimate the dependent variable. So we are estimating the consumption pattern, okay, from the non values of the independent variable. Suppose if we know the income and wealth of a person, okay, then we can estimate the unknown values of the dependent variable. Suppose if there are 20 peoples, okay, 18 people, for 18 people we know their consumption, their income and wealth. But there are 2 people, they are living in the same area, but we don't know about, they are not revealing their consumption, but we know their income and wealth. So from this non 2 values, income and wealth, we can find out the unknown values of the consumption. Okay, so that's the whole idea of the regression, and for that purpose we are using the regression analysis. Okay, then when we deal with the regression, okay, there is we have to understand that the regression does not necessarily imply causation. Okay, that means a statistical relationship cannot be logically imply causation. What does it mean? Regression does not imply causation always. If there is a statistical relationship between certain variables, it may not be real. For example, suppose I have taken consumption of this group, or consumption of a particular group who are living in Kerala. Okay, suppose I have taken 1000 samples from Kerala. I have taken only one variable called consumption pattern. I have taken the income of some other 1000 pupils from Jammu and Kashmir or some other state. We have done a regression. We will get the values. Okay, we will get the values. Suppose if we got a value 0.58 or 0.6, how you will interpret it? if income increase by 1 rupee in Kashmir, will be increase the consumption of Keralites by 0.6 percentage. Would you interpret this like? No, we cannot interpret, because we know that theoretically or hypothetically there is no relationship between consumption of Keralites and consumption of or income of the other states. Okay, so but we are here, if you have if there is an equation for regression, if you give the values and if you fit the regression model, you will get some values. But if you got some number, it doesn't mean that it is always related. Okay, so the causation will come from the theoretical background. If there is a proper theoretical background, then only the causation will happen. But if we have certain data, then the statistical relation can be established, but it may not be real relationships. Okay, that we have to be taken care. Okay, then for your undergraduate program, you might have learned about the correlation analysis. Okay, so correlation analysis is also a tool in statistics to study the relationship. Regression is also a tool to analyze the relationship. So what's the difference between regression and correlation? Okay, so in correlation, the primary aim of the correlation is to measure the strength, the direction, and degree of a linear association between two variables or more than two variables. Okay, so in correlation will always study the linear associations. Okay, and this correlation will tell us only whether there is a what is the strength of the relationship, or what is the degree of a relationship. Okay, what is the form of the relationship. Okay, then what is the form, what is the direction, and what is the degree of a relationship. It means that if it is whether it is a positive relationship or not, if consumption is an income relationship, whether it is positive or negative. Okay, then if it is positive or if it is negative, whether it is linear or non-linear. Okay, that is form. Then the degree, whether it is high degree correlation or low degree correlation, very high degree correlation, or exact correlations or perfect correlations. Okay, so only all these things will tell, all these things will get from the correlation analysis. Whereas in regression analysis, we are trying to estimate or predict the average value of one variable called dependent variables, okay, on the basis of the fixed values of the independent variable. So in regression analysis, we are going to predict the unknown values of the dependent variable from the known values of the independent variable. We know the values of independent variable, but we don't know the values of dependent variables. From the known values of the independent variable, we are going to analyze, or we are going to predict the values of the dependent variable. Okay, so that's the relationship between regression and correlation. In correlation will not deal does not deal with this prediction, okay, and estimation. It will give only an idea about is there is a relationship or not. If it is, what is the direction, positive or negative, what is the form, linear or non-linear, what is the degree, high, low, perfect. Clear? Yes. So in that sense, correlation has a limited use, okay, but the regression has unlimited use in economics, especially in econometrics. Okay, that's why we are saying that the regression analysis is the cornerstone of the econometrics. Econometric analysis is starting from the regression itself. Okay, yes. Then now, in order to make you understand about the linear or the regression analysis, let me take a simple linear regression model, SLRM. SLRM. Okay, what is SLRM? Simple linear regression model. What is that? Here we are assuming that there are only two variables, one dependent variable and one independent variable. Okay, then we will deal with multiple linear regression model later, where we will have more than one independent variables. Clear? Yes. So a regression model with one independent variable is known as a simple linear regression model. Okay, so in order to analyze, or in order to see what is the regression, or how we can derive the regression model, or how we can derive the regression equations, okay, we will see using simple linear regression model first. Then we will extend this simple regression model into multiple regression models. Okay, so in order to analyze, or in order to understand these concepts, let me take an example. Okay, so this example is a hypothetical example, it's not a real example. Okay, and there are total population is 60 families. As you know that there are population and samples, we are dealing with population. Assume that there is an area where only 60 families are living. We are taking all these 60 families, so it will be our population. Okay, yes. Then what we are going to take from this population, their weekly family consumption expenditure, how much they are spending, in a week for consumption purpose, and what is their family weekly income, or family disposable weekly income. Okay, it is called X, and income consumption is called or denoted by Y, and X is income is denoted by X. Okay, then there are 60 families, and almost all these 60 families, this 60 family we can subdivided or divided into 10 groups of same income, approximately the same level of income. Okay, so all these people, all these 60 families having approximately, some families is having approximately same income. Okay, so some families are having 80 income, 100, 120 up to 260. Okay, yes. Now let's see this is the total data that we have collected. Remember, we have collected the population, not the sample. Okay, yes. So look at this, 80, 100, 120. Okay, in 80 means what? The income is 80 rupees. Okay, and there are 1, 2, 3, 4, 5 families is having the same level of income, 80, but their consumptions are different. Look at a first household is having 55, then 60, 65, 70, 75. Even though the income level is same, but each household's consumption levels are different. You look at the next one, 100. Their income is 100 rupees, but they are spending differently. It is vary from 65 to 88. Okay, then 120 income levels, there is a difference. So you look at all these things, even though the incomes are same, but they are spending differently. That's my point here. Okay, so we have collected all this data. This is 60 people or 60 household consumptions are there, their income levels is also there. Okay, then here let me tell you one thing. Okay, so here let me find out what is the conditional mean of Y. So I am introducing a new term, conditional mean. What is conditional mean? The average is of certain items. All these certain item has a unique feature. That is conditional. Okay, so here in the first case, the total value is 325. The 80 rupees, the income level is 80. There are 5 families who are having the 80 level of income. Their expenditure is different. But if you take the average of all these 5 family, that means if you add all these 55, 60, 65, 70, 75, you will get 325. Divided by 5, you will get 65. Okay, so this 65 is what? Average level of consumption of those who have 80 level of income. So this 80 is a condition here. Okay, so in this 65, when we find out the 65 as an average of this group, other income groups or other persons' consumptions are not included in this. In this case, we have included only those people whose incomes are only 80. That's why we are saying that this y is conditional mean is, or conditional mean of y is this 65. This is conditional upon the there's a group called 80 level of income groups. This average is only depends on this 80 level of income groups. Okay, then we have find out all such average for each income groups. Okay, so this is known as 65, 77, 89, 101 up to 173 is known as conditional mean of y, or conditional mean. Okay, because this is not a real average but is conditional average. Okay, there is a condition always. Okay, then now now we are going to tell you, if you draw a graph of this data. Okay, if you draw a graph for this data, 60 families, what you will get? Look at the graph. You will get a non-linear. Okay, you will get a linear but not proportional, not non-linear. Okay, linear but not proportional graph like that. Okay, so from this graph, what you can understand? We can understand that even though there are variability in consumption expenditure within each income groups, on an average, consumption is increasing when the income level is increasing. Okay, so from this graph, what we are going to infer is, even though there are considerable variations in each income groups, okay, but on an average, when consumption is increasing, when income is increasing, the consumption is also increasing. Okay, yes. So we have got that whenever the income increases, as a whole, consumption is also increasing. Okay, then I have told you about the conditional mean. Okay, so this conditional mean is denoted by expectation of y given x, expectation of E of y given x. Okay, this is expected value or average value of y conditional upon x. Okay, then there is an unconditional mean. What is unconditional mean here? Unconditional mean is nothing but if you add all the consumption of 60 families and you divide by the total number of families, that is 60, you will get what is unconditional values. Okay, so if you add all such 60 families consumption expenditure, you will get 7,272. You divide with 60, you will get almost 121.2 rupees. Okay, so this is the average of the total 60 families. Earlier what we have find out, average consumption of a given income level families. Okay, so there will be more than one or two conditional mean, but there will be only one unconditional mean. Okay, so in degree, when in undergraduate level, whatever we have learned or whatever the average we found is what? Found is unconditional mean, but if there is any condition for calculating the mean, then it will be conditional mean. Is it clear? Yes. Now, let me tell you what is the population regression line, or what is the population regression curve. Okay, so if you, now we have find out the conditional mean. Okay, if you join all the conditional mean value, we will get a curve. This curve is known as population regression line. Okay, so we have find out the conditional mean, then we have drawn a curve through all these conditional mean values, then we got a straight line. Okay, straight linear non-proportional straight line. This straight line is known as population regression line or population regression curve, PRL or PRC. Okay, so what this figure shows? This figure shows that for each x there are y values, okay, that are spread around a conditional mean of those y values. What does it mean? There are, for a given level of x, there are y values 1 2 3 4 5. Okay, then if we find out this average, we got conditional mean value. Okay, then all other values are spread around these conditional mean values. Okay, you look at here, okay, so there are certain dots you can see. Look at the first one, certain dots are there. Okay, in 80 level of income, 1 2 3 4 5 household are there. Okay, then you know that point where this line is passing through, that line is known as the conditional mean values. Okay, so above this conditional mean and below the conditional mean, there are certain consumption expenditures. Okay, but the conditional mean values will be in the middle of all these values, and it will be symmetric. Okay, yes. Okay, so these y values are spread around these conditional mean values. Okay, and these values are distributed symmetrically around their respective means, and all this regression PRL is always passes through this conditional mean values. Okay, so PRL is a locus of the conditional means of the dependent variable for the fixed values of the explanatory variables. I hope you know or you got what is the PRL is. PRL is nothing but locus of the conditional mean values of the dependent variable. First, we find out this conditional mean values, then you join all the conditional mean value, then we will get PRL. Okay. Now, let me explain you what is population regression function. Now what we have discussed, population regression line. Okay, now from line we can find out what is a function is. Okay, so now what we can do is, we have a line, we have a graphical representations. Okay, that graphical representation we can convert into a mathematical form. Okay, so if we converted the regression line into a mathematical form, it is known as PRF, population regression function. And why it is called population regression function? Because we are dealing with population, not the sample. Okay, so from the preceding discussion or from the preceding PRL, we understand that conditional mean is a function of x. Okay, that's why in the first case, what's our conditional mean? Our conditional mean was 65. Okay, so why we have got this 65? Because we are taking only those groups of those group of family whose family income is 80. Okay, suppose if you change the family, if you change the x, this y will also change. Okay, that's why we are saying that this expected value of y is depends upon x. Whenever your income change, or whenever you change the group of the income levels or income level, then your conditional mean will also change. Okay, if there is one changes in the values of a group from a group, then your conditional mean value will also change. Okay, that's why we are saying that expected value of, or expected values means what? Average value or mean value. Average value of conditional, average value of y, or average value of consumption expenditure depends upon xi. Xi means what? Income level. You got? And this is what we call the population regression function PRF, or population regression PR, or there's one more name is there, conditional expectation function CEF. Okay, and commonly it is known as PRF. Okay, so what now we discussed, what is the conditional mean value, what is the unconditional mean value, what is PRL, and what is PRF. You got the point? Yes. So now come to the linear PRF. Linear PRF. Okay. So what is this linear PRF? Now we are going to make a change in our PRF. Okay. So in most of the cases, we don't know the real population. Here we know the population. Now here we are assuming that we know the exact number of population, that is 60, fixed. Okay, but in most of the cases we don't know the PRF. Okay, so what will be the function? The function will be usually derived from the theory. Okay, so in our example we are dealing with consumption and income relationship. So we know that the consumption and income relationship is linear and non-proportional, or it is linear. Okay, so what we can do, we can convert our initial PRF into a linear PRF. Okay, earlier what we have done, expected values of y given x is a function of x. That is, we have expressed this in the functional form. So same functional form can be rewritten as, or rewritten in the form of a linear form. Okay, so when we write in the linear form, what will happen there? There will be one intercept and one slope coefficient. Okay, so now what we have done here, now we have changed the initial PRF into a linear PRF. So it is B0 or beta 0 plus beta 1 x. Expected value of y depends upon beta 0 plus beta 1 x. Beta 0 will capture the intercept. Okay, so the area from 0 to the line, and the beta 1 will be capture the slope of the line. You got the point? Okay, so now we have converted this PRF into linear PRF. Okay, yes. Then now what is the stochastic specification of PRF? Now again we are going to make some changes in the linear PRF. Okay, now we are going to tell you, or now what I'm going to discuss is what is the stochastic specification of PRF. What is stochastic specification? Is nothing but we discussed error terms. Okay, so now we are going to add this error term in our equation. Okay, so what we have done, y is equal to expected values of, so y is equal to beta 0 plus beta 1 x plus u. Okay, now we have added u into the equation. What is this u? U is a random variables that will capture all the omitted variables from the model that will have an impact on our dependent variables. Okay, okay. So stochastic specification PRF is nothing but a PRF with a stochastic term, a PRF with a error term. Okay, so this now look at the equations. Yi is equal to expected value of yi given xi plus ui. Okay, so consumption is equal to expected consumption for a given level of income plus ui, or yi is equal to beta 0 plus beta 1 xi. So this beta 0 plus beta 1 xi is equal to is nothing but it is expected values of yi given xi. Okay, so this equation is having two components. The first one is the fixed component and another one is the random component. Okay, so look at this equation, yi is equal to beta 0 plus beta 1 xi. This part is known as fixed component and ui part is known as random component. Okay, so these expected values of yi given xi tell us that consumption expenditure for a group of family is depends upon the consumption expenditure of all the such families with same level of income, which is systematic and deterministic. We can determine it. Okay, whereas ui is a purely random variables. Okay, it's a proxy for all the omitted variables, which is non-systematic component, which we cannot have any control over that. Okay, it's purely a random variable, we don't have any control over that. But the first part is systematic part or deterministic part. Okay, so for our equation there is a systematic or deterministic part and stochastic part. Okay, stochastic part is nothing but ui, all other part is known as deterministic part. Okay, yes. So what we have done so far, conditional mean, unconditional mean, PRL, PRF, LPRF, stochastic specification of LPRF. Clear? Yes. Now we are coming to the sample regression function. Earlier what we have discussed, PRF, population regression function. Okay, so now come to the reality. We cannot always collect the data from the population. Here we had only 60 families, that's why we have gone for populations. Okay, but most of the time we don't have population, we don't know the population, but we are taking certain samples. Okay, so from the same population we have taken a sample, or we have taken randomly one sample. Look at these things, 55, 80, 88, 100, okay, 120, 90. Okay, we have taken one sample, then we have taken one other sample also. Okay, then we graph it. Look at the graph. The same idea that we have got from the population PRF, the same ideas we are getting from here itself. Okay, both are positively related. Okay, and whenever the income increases, the consumption is also increasing in a linear way and non-proportional way. Okay, so the idea is in both things, in population and sample we are getting the same idea, and whenever the income increases, consumption is also increasing. Okay, so look at the graph. There is a small difference in the shape of the graph, but that difference is very minute. Okay, then if you compare this graph with your PRF, that's also will be same, and we won't feel any huge differences between this graph. Okay, so this is what we call the SRF. So SRF is nothing but what? Is a locus of points of all the values in a sample, x values and y values. We are drawing a graph using the combination of this y and x. Okay, but in PR, what we have done in PRF, we have taken the conditional mean value, but here we are not taking the conditional value, we are taking all the values, and in between all these values we are drawing a line. Is it clear? Yes. Okay, so look at this graph. All these PRF dots are, we have drawn a PRF in such a way that all points are being connected. But look at this SRF1 and SRF2. Here the points are not exactly connected. Okay, in this case what will happen, for this y and x there will be an average. Okay, for y there will be an average, y bar, and x is an x. For x there's an average called x bar. This line will be passes through this y bar and x bar. Clear? So above this y bar and below this y bar and x bar there are certain points. Okay, so what will happen this point that we will see in later. Okay, yes. So look at this SRF. You see the SRF and you see the PRF. You feel the difference, how this is too different. Okay, now we come to the SRF. Now earlier we discussed sample regression line. Now we come to the sample regression function. What is the sample regression function? The same idea. You convert your sample regression line into a mathematical equations. It will be SRF. The same idea that we are getting here. Okay, what we do here, instead of earlier we have taken beta 0, beta 1. Here you take small beta 0, beta 0 or B0, B1, xi plus ui. Then there will be that we will discuss later. So here y is equal to beta 0 plus beta 1 xi plus ui. The only difference is that earlier we have taken the idea from the population, but here we are taking idea from the sample. Okay, then the below the written part is about how to find out the values of y cap and u cap. That we will see later. Okay, yes. Then SRF is okay. Then coming to the objective, what we are aimed at, what we want to do in regression. In regression we are having PRF. PRF is nothing but it deals with total populations. Okay, so our primary objective is what? To analyze or to estimate the population regression function. Okay, but we know that in rare cases only we know the PRF. In almost cases, in many of the cases we know only the SRF. Okay, so our primary objective is to estimate the PRF on the basis of SRF. Okay, most of the case we don't know the population, we only know the sample. So in regression, what's our aim is to estimate the PRF on the basis of SRF. So first you estimate the SRF, then from SRF you infer what will be the PRF. Okay, so look at in both equations you can see beta 0, beta 1, beta 0, beta 1. Okay, or in sample regression I have taken a small beta 0 cap and beta 1 cap. Okay, it is nothing but to identify this beta cap is SRF and beta 0, beta 1 is PRF. Okay, for that purpose only. Okay, or you can simply put small b0 or b1. Okay, understand that it is SRF and the previous one is PRF. Okay, then when we estimate this PRF and SRF, okay, what's our aim? If we estimate SRF, so suppose we estimate SRF, we got beta 0 is 20 and beta 1 is 0.5. Okay, then we estimate the population. That time we have got beta 0 is 22, beta 0 is 30 and beta 1 is 0.8. What does it mean? SRF, there is a huge difference between SRF and PRF. Okay, so that should not be there. The SRF and PRF should be very close to each other. There should not be indifferences. So my question is how to do such kind of how to get such kind of an SRF, or how to construct SRF so that beta 0 cap is very close to beta 0 and beta 1 cap is very close to beta 1 as much as possible. Okay, so our aim is to construct such an SRF. Our aim in the regression analysis is to construct such kind of a sample regression function. Then how can we do that? How can we do that? Either we can draw scatter plots and see the direction, intercept and slope. You draw you take as much as samples, okay, then you draw the scatter plots and see the directions, and you estimate its slope coefficient and estimate the intercept. Okay, but this job is very laborious. Okay, so what we can do is describe the relationship between y and x in a mathematical form that best fit the data. Okay, so what I'm trying to tell you is our aim of the regression is to estimate the PRF, population regression functions, but we don't know the population regression function always. We only know the SRF. So from SRF you find out the SRF first, then you infer your PRF from SRF, and the condition is that PRF and SRF should be there should not be any that much difference, should be almost same. So how to get such kind of an SRF? Okay, so the answer is what? The answer is regression analysis. From regression analysis we will get, using the regression analysis or what we call the ordinary least square method, we will get an SRF that will be almost equal to this PRF. Okay, so that's all about today's video. I hope you understand the concept which I explained in this video. Okay, so in the next video we will discuss what is simple regression line and related concept to this SLR. Okay, so thank you all. Thank you very much. Hello, welcome back to one more video about an econometric topic, regression. In previous video we discussed some of the basic concept about regression. What is regression? Then what is conditional and unconditional mean, PRF, PRL, then linear PRF, then stochastic specification of PRF, then sample regression line and function SRL and SRF. Then what is the aim of the regression, or what is the fundamental objective of the regression? It is nothing but to estimate the PRF, but the PRF is not directly observable. So we use to SRF, then estimate the SRF, then we infer what is the PRF. Okay, so that's the fundamental aim of the, or fundamental objective of the regression analysis. Okay, so in this lecture, in this video, what I am going to discuss with you is some of the very basic concepts about simple linear regression model. Okay, so before going to regression methods or regression modeling, we need to understand certain concept. Okay, that's we are going to see in this video. So let us discuss the first of things. The first thing is, what is a regression? What is SLRM, simple linear regression models? Okay, SLRM is nothing but it is a regression equation where there will be only one dependent variable and one independent variable. Okay, or simply we can say that a regression model with only one explanatory variable is called a simple linear regression model, or what we call two variable regression model. Okay, so a two variable regression model will look like yi is equal to beta 0 beta 1 xi. Okay, so why I am putting yi here? Because I am dealing with cross-section data. Okay, so if I put yt, then it means that I am dealing with time series data. Clear? Yes. Then as I told you before, this equation is a deterministic equation. Okay, or this equation tells us the exact relationship. Okay, so if we know the values of beta 0 and beta 1, we can certainly determine the value of y for each value of x. Okay, but as I told you before, the deterministic relationship will not exist in economic relationship or statistical relationship. Okay, this you can clearly understand if you just plot this data in a scatter plot. It suggests that for each value of x, there could be many different values of y. Okay, so for each income groups, there are different values of y. What does it mean? Even though the income level are same, the people consumption patterns are different. That's why we are saying that this relationship is not exact, or this relationship is not deterministic but inexact. Okay, so what we have to do, we will add a stochastic error term. So our equation will be yi is equal to beta 0 beta 1 plus beta 1 xi plus ui. So this is the simple linear regression model or regression equations. Okay, then in this equation we are using certain notations. Okay, what is this y is, what is beta 0, what is beta 1, what is xi, what is ui? All these things we will discuss in detail in this video. Okay, so the next thing is, what is this y? Our equation starts with y. yi is equal to, what is this yi? yi is a dependent variable or explain variable, predictant variable, regression variable, response variable, or endogenous variable. All these are same. All these are all some of the name of the dependent variables. Dependent variable, explain variable, predictant, regression, response, endogenous variables. Clear? Okay. So in some book you can see that they have used the term explain and explanatory variable. Okay, in some book they have used predictant or regressor and regression. Okay, so you have to understand that whatever they have used, if you are seeing all these still, then you have to understand that it is nothing but a dependent variable. Clear? Yes. Now this dependent variable y is a random variable. Okay, so I hope that you have read the material that I have provided. What is a random variables? Okay, so y is a random variable. It can be measured on 4 different scales. This variable, what is our y? Y is a consumption here. Okay, so a y or a dependent variable may take 4 scale. There are 4 measures of scale or scale of measurement in statistics. Okay, so these 4 different scales are depends upon or is based on 4 criteria, or broadly there are 3 criteria and we can add one more criteria, so there will be 4 criteria. First one, whether the ratio of 2 values in this variable has meaning or not, or whether a ratio of 2 variable has any meaning or not. What is ratio means? A value divided with another value. Okay, so that's our first property or first condition. Okay, the second condition is whether the distance between 2 variables has any meaning. What is distance means? Just subtract. Okay, yes. The third thing, whether we can order these values in any of the order or ascending or descending order. And last one more thing is there, whether there is a meaningful zero exist or not. First, whether the ratio has any meaning. Second, the distance has any meaning or not. 3, the ordering is possible or not. 4, meaningful zero is possible or not. Okay, so if a variable is there that satisfy all these 4 criteria or conditions, then such a variable is known as purely quantitative variable, or what we call ratio scale variable. Let me take an example. GDP. Okay, what does GDP means? What? GDP, your income, your consumption expenditure, all these things are ratio scale variable, because if you subtract a GDP figure with another GDP figure, what you will get? You will get a value, isn't it? Yes. Then if you subtract a GDP value from another GDP value, you will see the difference. Okay, then you can say that in a particular year the GDP is less than that of the previous year. You can order the GDP. Then sometime there may be a zero may be possible. In GDP case it may not be possible, but if you take the income levels, then the zero may be possible. Clear? Yes. So if a variable that satisfy all these criteria, then such variable is known as a ratio scale variable, or it is known as purely qualitative variable. Is it okay? Yes. The next one, interval scale variable. What is meant by interval scale variable? Interval scale variable, the second and third properties are only meaningful. The first and the last property doesn't exist. Such variable is known as interval scale variable. For example, the temperature level. Okay. So in Malappuram district, the temperature is 31 degrees Celsius. In Calicut, it is 29 degrees Celsius. Okay. You divide these two. What you will get? You will get some number, but it cannot be interpreted. It may not give any meaningful idea, isn't it? Yes. So, or you take year. Year is a variable. Okay. 2020 is the present year. The previous year was 2019. You divide 2020 to 2020 divided by 2019. What you will get? You won't get anything. Clear? But the distance has meaning. What is that? Malappuram district 30 degrees Celsius, Calicut 29 degrees Celsius. What does it mean? Malappuram is hotter than Calicut by 1 degree Celsius. It has a meaningful. Okay, then 2020 minus 2019, 1 year. The duration in between 2020 and 19 is 1 year. You will get a meaningful idea. Okay, then the ordering is also possible. Malappuram is greater or hotter than Calicut. That is the ordering. Okay, or 2020 is the newest year than 2019. So ordering is possible. So these two conditions, the distance has meaning, ordering is possible. Such kind of a variable is known as interval scale variable. Is it okay? Yes. Then coming to ordinal scale variable. What is ordinal scale variable? Only the third property is meaningful. All other properties will not exist. Take the case of your grade. Your grade is look like A, B, C, D, E, or A plus, B plus, C plus, something like that. Okay? You divide your grade. Your grade is A plus. Another person grade is B plus. Okay? You divide A plus divided by B plus, what you will get? Or A divided by B, what you will get? You won't get anything. A minus B, what do you get? Nothing. But you will get that, you can say that A is greater than B. Okay, similarly, you take the different types of soft drinks, Pepsi, Coca-Cola or Mirinda, 7-Up, like that. Pepsi divided by 7-Up, what you will get? Nothing. Pepsi minus 7-Up, nothing. but Pepsi is better than 7-Up. You can say, or 7-Up is better than Pepsi. You can say like that. Okay, but here the third property is only meaningful. Okay, the last one is nominal scale variable. The peculiar feature of this nominal scale variable is it won't satisfy any of this condition. Okay, it won't satisfy any of this condition. The distance has not meaning. Ratio will not work. We cannot order it. 0 may not exist. Okay, you take the gender, male female difference, or male female. Male divided by female, what you will get? Nothing. Male minus female. Male is better than female. A male is greater than female. No. Then male is 0. Nothing. Okay, so if all these properties are satisfied, it is purely quantitative variable known as ratio scale variable. Just opposite of this, exact opposite of this. 4 of those properties are not meaningful, called purely qualitative variable. Okay, so nominal scale variable. In between these two, certain cases that is qualitative but not purely qualitative. Such kind of variable is known as interval scale variables. Okay, sorry, if such variables known as ordinal scale variable, and there are some variables that is not purely quantitative but it is quantitative. Such variable is known as interval scale variable. Clear? Yes. So this is the nature of their y variable. Okay, y is dependent variable. There are so many names for that. This dependent variable will take any of these 4 variables. But in our cases, in consumption cases, it is the ratio scale variable. Okay, so this y variable not only take this ratio scale variable, but it will take interval scale, ordinal scale, and nominal scale variable. Clear? So we will see the examples later. Okay, so the next thing, what is the probability distribution of this y? Okay, so this y is a linear function of u. Okay, y is a linear function of u because y is a function of x plus u. Okay, so it is a linear function of u. And since ui is normally distributed, that we will see later, okay, the error terms are normally distributed, then this yi is also normally distributed. Okay, this we will see later. Okay, so in the previous, now I have given you one material. In that material I have shown you that I have given what is the random variable, what is the property of the mathematical expectation, variance, covariance, and all. Okay, so I am using some techniques from that material. Okay, here what is the expected value of yi? Here we have our equation is what? Yi is equal to beta 0 plus beta 1 xi plus ui. Take the expectation of this, find out the average of this. So this would be, say, expectation of yi is equal to expectation of beta 0 plus beta 1 x plus u. Okay, then as I told you before, this equation is consists of both deterministic part and non-deterministic part or stochastic part. Okay, u is the stochastic part and beta 0 plus beta 1 xi is the deterministic part. Okay, then since the expected value of ui, that we will see later. Okay, since the average value of ui is always 0, so what will be left in our equation? Expected yi is equal to expected beta 0 plus beta 1 x. Okay, then since the expectation of a using some of the properties of the expectation, we can write expected value of yi is equal to beta 0 plus beta 1 x. Okay, that for that how we got this expected yi is equal to beta 0 plus beta 1 xi, you see the material. Okay, yes. So coming to the weight, so what is the expected value of yi is equal to beta 0 plus beta 1 x. Okay, then what is the variance of y? Variance of y can be written in the form of expectation. Okay, so variance of y is equal to expected yi minus expectation of y whole square. Okay, so we know that what is y here. Yi is equal to, y means what? Y means the total equation beta 0 plus beta 1 x plus u. What is expected y? Expected y we got just before, beta 0 plus beta 1 x. You subtract it, then what left in this equation? Only u will left. So it will be variance of y will be equal to expected u, then square is remain there, so expected ui square. Okay, so this will be our variance. So the variance can be written as small sigma square. So variance y is equal to small sigma square or expected ui square. Clear? So this y, what is the expectation of this y? Beta 0 plus beta 1 x. What is the variance expectation of ui square or small sigma square? Okay, so what I am trying to say at, this dependent variable y is normally distributed because y is normally distributed with beta 0 plus beta 1 x as the mean and small sigma square as the variance. Clear? Yes. Then coming to the x. Okay, so in our equation y and x are variables. Y is dependent variable, x is independent variable or explanatory variable. Okay, so we have discussed about dependent variable. Now we come to the independent variable. Okay, so x is called independent variable, explanatory variables, predictor variable, regressor, stimulus, control or exogenous. Just opposite of the previous one. Okay, where we find explain variable, here is explanatory variable. Dependent variable, independent variable. Predictant variable, predictor variable. Regressant, regressor. Then stimulus or control variable. Then earlier we discussed endogenous. Here we have, so earlier we have discussed response variable, just opposite of that, stimulus variable. Then exogenous, endogenous variable. Okay, so all these are all the same name. That is denoted for the explain variable or explanatory variable or independent variable. Okay, so I hope that you understood what is independent and dependent. Okay, dependent means what? This variable y is dependent for something. Okay, just example, y is a function of x, y is consumption is a function of y. Consumption depends on y and y is independent of consumption. What does it mean? Whenever your income increases, your consumption will increases. But whenever your consumption increases, it may not increase your income. Okay, so consumption is depends on income, but the income is independent of your consumption. Whenever your consumption increases, it may not increase your income. Clear? Yes. Okay. In classical regression model, it is assumed that the independent variable x is not random. Okay, so y is a random variable, but x may be a random variable and may not be a random variable, and this variable can also be measured on for different scale. Okay, then in classical regression model or in regression model, we are assuming that these values of x are fixed in repeated sampling. As a result of the regression analysis is conditional upon the fixed values of the regressors. Okay, so since earlier we have seen that this the x is the income level is same, 80. Okay, there are 5 different households, they are having the same level of income. Okay, so here this income is fixed for different households. Okay, that's why they're saying that sometimes it may be assumed that the x may be fixed, okay, in repeated sample. Okay, so more about this thing we will discuss when we discuss about the assumptions of regression analysis. Okay, yes. Then coming to the nature of the y or nature of the u variable. As I told you before, stochastic disturbance term or error term is a variable, is a surrogate for all variables that are omitted from the model but they collectively affect y. It's a variable or it's a group of variables, okay, that is included in our model because it will have a collective effect on the dependent variable. Okay, for example, in our consumption function, y consumption is a function of income. Apart from income, there are some factors. Okay, that someday it may be measured and someday it may be not measured or listed or not listed, no problem. But individually they may have a very negligible effect on y, but collectively they may have some effect. Okay, so such a variable is known as, so instead of such a variable we are putting a term u. You will collect all the, what is the total effect of this unobserved variable. Clear? Yes. And why we are including these error terms? There are large number of reasons for that. Okay, so when we discuss about the methodology of econometrics, we discuss some of these variables. Okay, the first one is all those variables that cannot be readily quantified. There are certain variables that we cannot readily or exactly quantify. So what we do? We will omit that variable and instead of that variable we will put you will capture this effect. Okay, then in some time the data may not be available. For some variable the data may not be, or clear exact data may not be available. In such situation what we do? We will remove that unavailable data variable, then don't worry about it, the u will capture it. Okay, then errors in the measurement of the data, the model misspecification and functional misspecifications. Okay, suppose if we commit some mistake in specifying our model, or we take incorrect specification for something. Okay, what is incorrect specification you got? Okay, so in estimating a cost curve, average cost curve, what we have to do? We need to specify a quadratic function. Suppose instead of that we specify a linear function, we committed a mistake. Okay, so this type of a mistake will take care by this u. Okay, then intrinsic randomness in human behavior. What is the intrinsic randomness in human behavior means what? This says that human behavior are not predictable. Even though there are 10 members in the same family, all these 10 members will behave differently. Similarly, if there are 100 people, some fellow has given this 1,000 rupees for all these 100 people, okay, and he said them to spend it. All these 100 people will spend this 1,000 rupees differently, because human behavior are unpredictable. We cannot predict. Okay, this is what we know as intrinsic randomness in human behavior. Okay, human behaviors are different or unique for different individuals that we cannot predict or that we cannot model. Okay, so in order to include such kind of behavior, what we have to do, we will put you will take care such kind of intrinsic randomness in human behavior. Okay, then poor proxy variable. What is poor proxy variable means? There are in certain cases the exact variable or exact data may not be available. For example, you take the case of India. If you want to measure, or if you want to verify Keynesian liquidity preference theory, the theory says that the demand for money is positively related to income and negatively related to interest rate. And if you want to verify this theory for India, what we have to do? We need money supply data. Okay, we need income data. GDP is there for income. We know that GDP is just a proxy, not an exact figure for measuring the income level. Okay, then we need interest rate. For India, we don't have a unique interest rate. We have a different series of interest rate. So which interest rate we will take? Sometimes we can take the treasury bill interest rate or carbon interest rate. Okay, so all these things, in all such kind of things, we don't have a proper proxy or proper variable. Instead, what we have to do, we are having, or we will take some proxies. Okay, these proxies may not capture all the things perfectly. Okay, so for accounting such mistakes happening in taking the proxy variable, don't worry about that, thus you will capture it. Okay, and last one is the principles of parsimony. What this parsimony says, or parsimony principle says, parsimony principle says that the equation should be simple as possible. The economic model should be simple as possible. Okay, suppose there are in consumption equation, there are large number of variables that will affect our consumption. Okay, there are 10 variables, 15 variables. We cannot take all these variables, our equation will be very large. So what we have to do, we have to reduce the equation, or we have to adopt principles of parsimony, or the equation should be simple as possible. For keeping the equation simple as possible, what we have to do, you remove certain insignificant variable, then include u in the equation. Okay, yes. And sometimes the theory may be vague. Okay, in that case also we can rely on this error terms. Okay, so these are all certain reasons for why we are including error term in the equation. Clear? Yes. Now, so far we discussed y, x, u. Okay, some things are left there. Okay, beta 0, beta 1. What is this beta 0, beta 1? Okay, so in classical linear regression model framework, the main idea is, okay, this variable or these parameters beta 0 and beta 1s are fixed numbers and not random numbers. Okay, but even though we don't know the actual values of this variable will be a fixed value for all people. Suppose there are 60 members in our equation. Okay, but if we, how many beta 0, beta 1 values will be there? Only one. Okay, because this beta 0, beta 1 will tell us the average. Okay, so there will be only one figure for that. Okay, and our aim is to measure this unknown fixed non-random parameters. In regression, what's our aim? To estimate or to find out the unknown values of beta 0 and beta 1 from the known values of y and x. Clear? Yes. Then why I'm used beta 0 and beta 1? Why cannot use a or b, something like that? It's up to you. Okay, so in econometrics, what we are actually doing is we are denoting the coefficients or parameters using Greek letters. In econometry, you can see that they have used the Greek letters. Okay, they have used Greek letters. So that's why we are using Greek letters. And if you have any problem with Greek letters, then don't worry, you can use A, B, C, something like that. That also you can use. Okay, so what I am trying to say that in many books, they have used many coefficients. Okay, so in our classes, what we will use alpha, beta, or beta 0, beta 1, beta 2, something like that. Okay, but in some book they have used alpha, beta, theta, gamma, lambda. Okay, then pi, tau. Okay, but these are all certain Greek word or Greek letter or Greek alphabet. Okay, that have used only to denote a coefficient. Okay, so these are just an alphabet. Don't confuse with that. If a book has used beta 0 and some book they have used theta, both are same. Okay, the shape of this letter won't tell anything, but the idea of this equation will give us give you the idea. Okay, not this the shape of this alphabet. Clear? So these are all some of the Greek letters. If you don't know the Greek letter, you have to learn this. Okay, alpha, beta, gamma, delta, epsilon, zeta, eta, pi, then theta, lambda, mu, pi, rho, sigma, tau, omega. Okay, these are all some of the Greek letters that we use regularly in our teaching or in our learning process. Okay, so please understand what all these what is the shape of these letters and how to pronounce these letters. Is it okay? So I think we have explained all the notations related to simple linear regression model. We explained what the equation is all about. Okay, then what is dependent variable, the scale of the dependent variable, then the distribution, the probability distribution of this y, what is the expectation of this y, what is the variance of this y. Then we have seen the explanatory variable or independent variable, then error terms, reason for error terms, then we have seen parameters or beta 0 and beta 1. Okay, so these are all about this today's lecture or today's video. Okay, I hope it is understood, and if you have any doubts you can contact me. Thank you. Hello, once again back to econometric class. In previous videos we have discussed what is regression analysis, the terms such as Prf, Srf, and what is the objective of a regression. Okay, then we discussed various notation associated with a regression equation. What is dependent variable, what is independent variable, what are the parameters, what is u, what are the things this u will capture. Okay, so we have discussed all such kind of things. Okay, so in this video what I am going to discuss with you is how we can derive, or how we can derive the equation of a regression model. Okay, so the equation is that sigma xy, if you look at the books you can see that the beta 1 is, that means slope parameter is equal to sigma x into y divided by sigma x square, small x square. Okay, similarly beta 0 or the intercept parameter is equal to y bar minus beta cap 1 into x bar. Okay, so my question is that how we can derive these two equations mathematically. Okay, so as I told you, our aim of a regression is to select the values for beta cap 0 and beta cap 1 in such a way that the errors are small as possible. Okay, because the u cap is the error. If u cap values are less, then it means that the variations in dependent variable are better explained by the independent variables. Okay, whereas if the error terms values are much higher, it means that the other values are explain the variations of y than the independent variable that we attached. Okay, so our aim is to find out the values for beta cap 0 and beta cap 1 in such a way that the error should be minimum as possible, or it should be 0. Okay, so it means that sum of the errors sigma u cap is equal to 0. Sum of sigma u cap is equal to 0. Okay, so what is u cap? U cap is yi minus beta cap 0 minus beta cap 1 xi is equal to 0. Okay, so if you divide this equation with n, what you are getting here? Sigma y divided by n minus, okay, n into or beta cap 0 minus beta cap 1 xi divided by n. Okay, so we have got sigma yi divided by n is equal to y bar. Okay, sigma beta cap 0 mean beta cap 0 minus beta cap 1 x bar is equal to 0, because x minus n is equal to x bar. So it is y bar minus beta cap 0 minus beta cap 1 x bar is equal to 0. Okay, so if you solve it for y, then what you will get here? Y bar is equal to beta cap 0 plus beta cap 1 x bar. Okay, so y bar, average value of y bar, or average value of y is equal to beta cap 0 plus beta cap 1 into average value of x bar. Okay, so what does it mean? It implies that, or it means that beta cap 0 and beta cap 1 should be selected in such a way that the estimated regression line, if you draw a line after the estimation, it should passes through the y bar and x bar. So this is one of the property of a regression model. That means if the regression line will passes through the value of y bar and x bar. Okay, yes. So the next thing is, yes, okay, the next thing is, yes, the problem here that the thing is that we have to draw a line through x bar and y bar. Okay, but the problem is that we can draw as much as line with any slope through y bar and x bar. We can draw a number of lines through y bar and x bar. Okay, moreover, the thing is that sigma u cap is always is equal to 0, because the positive, there will be positive errors and there will be negative errors. Okay, the positive errors and negative errors will be exactly balance each other, and you will get sigma u cap square is equal to 0 always. So our aim is to reduce the errors, but if you sum the errors, it will be always equal to 0 because of the mathematical algebraic treatment. That means there will be positive errors and there will be negative errors. If you sum both, it will get 0 or it will get cancelled. Okay, so what we can do here, okay, so we can do one thing here. What is that? It is that you adopt a criteria called least square criterion. Okay, so what's mean by least square criterion? That it means that you minimize the sum of the residual, okay, or RSS. You minimize the RSS. Okay, so instead of sigma you squared it. That means you just square it. That means sigma u cap square it. Okay, so sigma u cap square, you then you minimize it. Okay, that means least square criteria means you select sigma u cap, you select a value for sigma u cap square which is minimum as possible. Okay, so that's why in regression or in OLS our aim is to minimize the squared error term or least square. Okay, that's why it is known as ordinary least square method. Okay, so what we are doing here, we are just squaring the u cap, sigma u cap square. Okay, so this will do two things. First thing, it will avoid the possibility of positive residuals and large negative residual could offset each other. That means the positive values will be there and negative values, the effect of the negative values will be there, and this both negative and positive errors will not be cancelled out. Okay, and second thing is that it will give larger weight to numerical large residual regardless of whatever they are positive or negative, whether a value is negative or positives. Okay, the weight will be equal when we square it. Okay, yes. Okay, so what we are doing in regression is we are just reducing, actually what we have to do is we have to reduce the errors. Okay, so first thing, we can reduce the error by summing up. Okay, but the problem is that the negative errors will be there, positive errors will be there, negative errors and positive errors will be cancelled out each other. Okay, so sigma u cap square will be always equal to 0. Okay, so what we have to do, you adopt a criterion. Criteria means what? Least square criterion. What is that? Minimize the squared error term. That means sigma u cap square, you minimize it. Okay, Yes. Then if the sum of the squared residual, or what we called RSS, if it is small, the regression coefficient will be better. Okay, and if sigma u cap square is equal to 0, our regression estimations or estimators will be best or perfectly fit, but even though it is not possible always. Okay, so what is meant by RSS? It is nothing but when we calculate the regression values or regression coefficients, okay, we will get u values. Okay, so for the first value we have u1, second u2, u3 up to un. It is nothing but our u values, u1, u2, u3, u4 and u5 up to un. Okay, then you minimize this, that means sigma u cap square. What you have to do, you minimize this. Okay, yes. Then using this criteria, how we can derive the regression coefficients. Okay, so for this thing, what I am going to do is I am just taking 3 examples or 3 numbers. Okay, assume that there are 3 observations. Okay, y values are 3, 5, 6, x values are 1, 2, 3. Okay, then what will be the y cap? Y cap and the y cap means beta 0 plus beta 1 into x. So here x is equal to 1. So beta 0 plus beta 1 x. That means 1 into beta 1. Second one, beta 0, the x is equal to 2 here. So 2 into beta 1. അടുത്തതോ beta 0 plus 3 into beta 1. അതാണ് നമ്മുടെ y cap എന്ന് പറഞ്ഞാൽ. ഓക്കെ, ഇനി യു ക്യാപ്പ് എന്താണ്? യു ക്യാപ്പ് ഈസ് നത്തിങ് ബട്ട് യു ക്യാപ്പ് ഈസ് ഈക്വൽ ടു y മൈനസ് y ക്യാപ്പ്. ഓക്കെ, സോ അവർ യു ക്യാപ്പ് ഇസ് ഈക്വൽ ടു y എത്ര ഇവിടെ? y is equal to 3 ആണ്. ഓക്കെ, 3 minus y cap. So 3 minus beta 0 minus beta 1. അടുത്തത് 5 minus beta 0 minus 2 beta 1. Next 6 minus beta 0 minus 3 beta 1. Okay, yes. Now what we have to do, assume that these are all our errors. u1 square, okay, this u1 square, this u1, this is u2, this is u3. Assume that there are 3 numbers only, so u1, u2, u3, this will be constitute our sigma u. Okay, yes. Okay, so if you do sigma u cap, this will be always equal to 0. So what we have to do, you have to square it. Okay, then how it would be? 3 minus beta 0 minus beta 1 square plus 5 minus beta 0 into 2 beta 1 square plus 6 minus beta 0 minus 3 beta 1 square. So this is u1 square plus u2 square plus u3 square. Okay, yes. Then the next thing what we can do is you solve this equation. That means you find out the value for u1 square plus u2 square plus u3 square. Okay, so u1 square 3 minus beta 0 minus beta 1 square. Okay, u2 square 5 minus beta 0 minus 2 beta 1 square plus 6 minus beta 0 minus 3 beta 1 square. So this is our equations. Okay, so you look at this term, it is just similar to a minus b minus c square. A minus b minus c square, you can simply expand it using a square plus b square plus c square minus 2ab minus 2ac plus 2bc. Okay, so you expand it. the first term. Okay, I'll show you the first term, how we can expand it. Okay, a square 9 my plus b square, b is equal to b0. Okay, so b0 square plus c square, beta 1 is c, so beta 1 square. Okay, minus 2ab. Okay, 2 means 2 into a means 3, so 2 into a 6 beta 0 minus 2ac. Okay, 2 into 3 into beta 1. Okay, that means minus 6 beta 1 plus 2 beta 0 beta 1. Okay, so this is the first term. Okay, similarly you can find out the second term and third term. So this is u1 square, this is u2 square, and this is u3 square. Okay, yes. Then what you have to do, you sum it. 9, 25, 36, 70. Okay, b0 square, b0 square, b0 square, 3 b0 square. Okay, b1 square, 4 b1 square, 9 b1 square. Okay, 9 4 13 1 14 b1 square. Okay, 28 b0, 62 b1, and 12 beta 0 beta 1. Okay, so we have find out. So this is what? This is nothing but sigma u cap square, that we have to minimize it. Okay, yes. So coming to our criteria, and then we have to minimize the RSS. Okay, so RSS means what? This is nothing but sigma u cap square, അതാണ് നമ്മുടെ RSS കേട്ടോ. Okay, so അത് നമ്മൾ minimize ചെയ്യണം. Okay, so how we can minimize? You adopt the minimization criteria. First order minimization criteria എന്താണ്? Dou RSS divided by, അല്ലെങ്കിൽ dou RSS with respect to dou beta 1, അല്ലെങ്കിൽ differentiate the RSS with respect to beta 1, so beta 0 first and beta 0 second. Okay, so what is our RSS? This is our RSS, 70 plus 3 beta 0 square plus 14 beta 1 square minus 28 beta 0 minus 62 beta 1 plus 12 beta 0 beta 1. Okay, yes. Then now how we can do that? Okay, first RSS with respect, differentiate RSS with respect to beta 0. Okay, where's the beta 0 here? Yeah, here is there's beta 0. Okay, then here's a beta 0, here's also beta 0. Okay, so how we can do that? 2 into 3, that means 6 beta 0 plus 12 beta 1 minus 28. Okay, 6 beta 0 plus 12 beta 1 minus 28. So with respect to beta 1, 28 beta 1 plus 12 beta 0 minus 62. ഏതൊക്കെയാണ് ബീറ്റ 1 ടേമുകൾ നോക്കുക, അത് മാത്രം ഡിഫറൻഷിയേറ്റ് ചെയ്യുക, അതാണ് പാർഷ്യൽ ഡിഫറൻസിയേഷൻ. ഓക്കെ, യെസ്. ഇനി എന്തായി നമുക്ക് എന്ത് കിട്ടി ഇവിടെ നോക്കാം. നമുക്ക് when we solve these two equations, okay, you solve these two equations. Okay, രണ്ട് simultaneous equations സോൾവ് ചെയ്യുന്നത് കിട്ടും നമുക്ക്. We have got y cap is equal to 160, അതായത് ബീറ്റ 0ക്ക് നമുക്ക് എന്ത് കിട്ടി 1.67 എന്നും ബീറ്റ 1ന് നമുക്ക് എന്ത് കിട്ടി 1.50 കിട്ടി. ഓക്കെ, ഈ വാല്യൂ കണ്ടുപിടിക്കുന്ന പ്രോസസ്സിൻ്റെ പേരാണ് ഓർഡിനറി ലീസ്റ്റ് സ്ക്വയർ മെത്തേഡ് എന്നറിയപ്പെടുന്നത്. ഓക്കെ, ഇപ്പോൾ നിങ്ങൾ കണ്ടത് നമുക്ക് ഇതായ നമ്മുടെ വാല്യൂ 3, 5, 6, നമ്മുടെ എക്സ് ഇതായിരുന്നു. ഓക്കെ, നൗ വി ഹാവ് ഫൗണ്ട് ദ വൈ ക്യാപ്പ്. വൈ ക്യാപ്പ് എന്താണ്? ഈ 1.67 പ്ലസ് 1.50 ഇൻറ്റു എക്സിന് നമ്മൾ എന്ത് ചെയ്യുക, വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് കൊടുക്കുക. എക്സ് 1 ഇല്ലേ, അതായത് മീൻ 1.67 പ്ലസ് 1.50 ഇൻറ്റു 1, 3.17, 1.67 പ്ലസ് 1.50 ഇൻറ്റു 2, 4.67, then 3 ആകുമ്പോൾ 6.17. ഓക്കെ, എന്നിട്ട് നമ്മൾ ഈ വൈയിൽ നിന്ന് എന്ത് ചെയ്യുക, ഈ വൈയിൽ നിന്ന് നമ്മൾ എന്ത് ചെയ്യുക, ഈ വൈ ക്യാപ്പ് കുറച്ച് കഴിഞ്ഞാൽ നമുക്ക് എന്ത് കിട്ടും, യു ക്യാപ്പിൻ്റെ വാല്യൂ കിട്ടും. ഓക്കെ, എന്നിട്ട് എന്ത് ചെയ്യുക, നമ്മൾ ഈ വൈ ക്യാപ്പ് ഉണ്ടല്ലോ, ഈ വൈ ക്യാപ്പിന് നമ്മൾ എന്ത് ചെയ്യുക, ഗ്രാഫ് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് കിട്ടുന്ന ലൈനിൻ്റെ പേരാണ് റിഗ്രഷൻ ലൈൻ. ഓക്കെ, യെസ്. ഈ ലൈൻ അങ്ങനെ പോവുള്ളൂ. ഈ ലൈന് ഈ രണ്ടിൻ്റെയും ഈ വൈൻ്റെയും എക്സിൻ്റെയും ആവറേജിലൂടെയാണ് എന്ത് ചെയ്യുക, ഈ ലൈന് കടന്ന് പോകുക. ഓക്കെ, അപ്പോൾ ഈ ലൈന് നമ്മളെ വരയ്ക്കാൻ നമ്മളെ സഹായിക്കുന്ന മെത്തേഡാണെന്ത്, ലീസ്റ്റ് സ്ക്വയർ, ഓർഡിനറി ലീസ്റ്റ് സ്ക്വയർ മെത്തേഡ്. ഓക്കെ, ഇനി ഇതിൻ്റെ ജനറലൈസ്ഡ് ഫോം ഉണ്ട്, ഞാനത് പറയുന്നില്ല കാരണം നിങ്ങൾക്ക് എക്സാമിനൊന്നും ആവശ്യമില്ലാത്തതുകൊണ്ടാണ് പറയാത്തത്. ഓക്കെ, ആവശ്യമുള്ളവർക്ക് എന്ത് ചെയ്യാം, മെറ്റീരിയൽ തന്നിട്ടുണ്ടോ എന്ന് നോക്കിയാൽ മതി. ഓക്കെ, എങ്ങനെയാണിത് ഡ്രൈവ് ചെയ്യാം. ഓക്കെ, ഇപ്പോൾ നമ്മൾ എടുത്ത എന്താണ്, ഇപ്പോൾ നമ്മൾ ഒരു 3 നമ്പർ മാത്രമാണ് ഇപ്പോൾ നമ്മൾ എടുത്ത് അല്ലേ. അപ്പം ശ്രദ്ധിക്കുക, ഇനി ഒരുപാട് നമ്പർ എന്താ ചെയ്യുക, അസ്യൂം ദാറ്റ് കണ്ടോ അവിടെ y1 y2 അപ് ടു yn വരെ നമുക്കുണ്ട്. ഓക്കെ, ഇവിടെ നമ്മൾ എന്താ ചെയ്യുക, അതേ സെയിം മെത്തേഡ് അഡോപ്റ്റ് ചെയ്യുക. ഫസ്റ്റ് നമ്മൾ y1 സ്ക്വയർ കാണുക, അല്ലെ u1 സ്ക്വയർ കാണുക, u2 സ്ക്വയർ കാണുക, ദെൻ un സ്ക്വയർ കാണുക. എന്നിട്ട് എന്ത് ചെയ്യുക, ഇത് നിങ്ങൾ നേരത്തെ ചെയ്ത് അതേപോലെ എക്സ്പാൻഡ് ചെയ്യുക. എന്നിട്ട് നമ്മൾ എന്ത് ചെയ്യുക, സമ്മ് കണ്ടുപിടിക്കുക. ഓക്കെ, അതൊക്കെ ഇതാണ് സമ്മ് കണ്ടുപിടിക്കുക എന്നാണ്. ഓക്കെ, അപ്പോൾ ഇതെന്താ ഈ കാരണം നമ്മുടെ ഈ സാധനങ്ങളൊക്കെ ഇതെന്താണ്, നമ്മുടെ RSS ആണ്. ഓക്കെ, ഇനി ഇത് നമ്മൾ എന്ത് ചെയ്യാണ്, ഇത് നേരത്തെ ചെയ്ത് അതേപോലെ എന്ത് ചെയ്യാണ്, നമ്മൾ 2 കണ്ടീഷൻ എടുക്കുകയാണ്, ദോ RSS ദോ ബീറ്റ അല്ലേ, അല്ലെങ്കിൽ ഡിഫറൻഷിയേറ്റ് RSS വിത്ത് റെസ്പെക്ട് ടു β0 ആൻഡ് β1. ഓക്കെ, നമുക്ക് എന്ത് കിട്ടി, ഈ 2 ഇക്വേഷൻ കിട്ടി. ഓക്കെ, ഈ 2 ഇക്വേഷൻ്റെ പേരാണ് നോർമൽ ഇക്വേഷൻ 1 എന്നും നോർമൽ ഇക്വേഷൻ 2 എന്നും കിട്ടി. ഓക്കെ, ഇത് കിട്ടിക്കഴിഞ്ഞാൽ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും, ഈ കിട്ടിക്കഴിഞ്ഞാൽ നമുക്ക് ഈ ഇക്വേഷൻ വീണ്ടും നമുക്ക് സോൾവ് ചെയ്യാൻ പറ്റും. എങ്ങനെ സോൾവ് ചെയ്യാം, ഫസ്റ്റ് നമ്മൾ ആദ്യം എന്ത് ചെയ്യുക, ഏതെങ്കിലും ഒരു ഇക്വേഷനിൽ നമ്മൾ എന്ത് ചെയ്യാണ്, നമ്മുടെ y ബാറിൻ്റെ വാല്യൂ എന്ത് ചെയ്യുക, ഈ ഇക്വേഷൻ നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കൊടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ വാല്യൂ കിട്ടും. കാരണം ഞാൻ പറയുന്നില്ല, ഒരുപാട് പറയുന്നില്ല. ഓക്കെ, യെസ്. അങ്ങനെ നമുക്ക് എന്ത് ചെയ്യും, അവസാനം നമുക്ക് എന്ത് ചെയ്യും, കാരണം അത് എക്സാമിനേഷൻ പോയിൻ്റ് ഓഫ് വ്യൂവിൽ അത് ആവശ്യമില്ലാത്തതുകൊണ്ടാണ് പറയാത്തത് ഞാൻ. അവസാനം നമുക്ക് എന്ത് കിട്ടും, നമുക്ക് ഇങ്ങനൊരു ഇക്വേഷൻ കിട്ടും നമുക്ക്. ഓക്കെ, β1 എന്ന് പറഞ്ഞാൽ എന്താണ്, സിഗ്മ XY. നമുക്ക് ഒരുപാട് മോഡൽ നമുക്ക് എഴുതാൻ പറ്റും, പക്ഷേ ഏറ്റവും കൂടുതൽ ആളുകൾ ഉപയോഗിക്കുന്ന മോഡൽ എന്ന് പറഞ്ഞാൽ ഈ സാധനമാണ്. അതായത് സിഗ്മ സ്മാൾ എക്സ് ഇൻറ്റു സ്മാൾ വൈ ഡിവൈഡഡ് ബൈ സിഗ്മ സ്മാൾ എക്സ് സ്ക്വയർ. ഓക്കെ, സ്മാൾ എക്സ് എന്താണ്, ക്യാപിറ്റൽ എക്സ് മൈനസ് എക്സ് ബാർ ആണ് സ്മാൾ എക്സ്. സ്മാൾ വൈ എന്താണ്, ക്യാപിറ്റൽ വൈ മൈനസ് ക്യാപിറ്റൽ വൈ ബാർ ആണ്. ഓക്കെ, യെസ്. അപ്പോൾ ഇങ്ങനെയാണ് നമ്മൾ എന്ത് ചെയ്യുക, റിഗ്രഷൻ്റെ ഈ OLSൻ്റെ പാരാമീറ്റേഴ്സ് നമ്മൾ ഡിറൈവ് ചെയ്തെടുക്കാം. ഓക്കെ, അപ്പോൾ എക്സാമിനേഷൻ പോയിൻ്റ് ഓഫ് വ്യൂവിൽ ഡിറൈവേഷൻ ഒന്നും പ്രധാനമില്ല. എങ്ങനെയാണ് ഈ ഇക്വേഷൻ വരുന്നതെന്ന് ചോദിച്ചാൽ അതിൻ്റെ പ്രോസസ്സാണ് ഞാൻ പറഞ്ഞത്. ഓക്കെ, അതേപോലെ അതിൻ്റെ അണ്ടർലൈയിങ് പ്രിൻസിപ്പിൾ അല്ലെങ്കിൽ അണ്ടർലൈയിങ് സ്റ്റാറ്റിസ്റ്റിക്കൽ തിയറി ഞാൻ പറഞ്ഞിട്ടുണ്ട്. ഓക്കെ, യെസ്. ഓക്കെ, അപ്പോൾ ഒന്നുകൂടി നോക്ക് നിങ്ങൾ, കാരണം ഓൺലൈൻ ടീച്ചിങ് ആയതുകൊണ്ട് ഒരുപാട് പ്രശ്നങ്ങളുണ്ട് ഈ മാത്സ് പഠിപ്പിക്കാൻ. ഓക്കെ, നിങ്ങൾ തന്നിരിക്കുന്ന മെറ്റീരിയൽ നോക്കുക, ഈ ഒരു നോട്ടും ഈ ഒരു വീഡിയോ വെച്ച് നോക്കുക. സംശയം ഉണ്ടെങ്കിൽ എന്നോട് ചോദിച്ചു കഴിഞ്ഞാൽ ഞാൻ പറഞ്ഞുതരാം. ഓക്കെ, hi all, welcome to one more classes in econometrics. In previous video we have seen that OLS estimators or regression coefficients that are derived through a process called OLS will be minimize the errors. Okay, and that's why we are calling it as a ordinary least square method. Okay, but in order to minimize the squares of the errors and thereby giving a best linear unbiased value for the OLS estimators, we need to satisfy certain assumptions. Okay, yes. So we will discuss what are these assumptions are. Okay, and in the examination point of view it is very important. These assumptions are very important. Okay, so there are mainly 3 categories of the assumptions. First category is assumptions about the model. Second is assumptions about the error terms. Okay, and third one is assumptions about the sample or assumption about the sample data. Okay, so these three are the major categories of these assumptions. Okay, so we will discuss this assumption by one. First assumption. Okay, so first assumption is the model is linear in parameter and the model is correctly specified. This is the first assumption. The model is linear in parameter. What does it mean, the linearity? Okay, it means that the beta 0 and beta 1, the parameters should be appear with power 1 and it should not be divided or multiplied with any other parameters. Okay, so it means that the power of the beta 0 and beta 1 should be 1. It should not be square, it should not be cube. Okay, and it should not be divided with any other parameter. Beta 0 divided by beta 0, beta 1, or beta 1 divided beta 1 into beta 0. It should not be divided or multiplied with any other parameters. Okay, and this linearity implies that a one unit change in the independent variable will have the same effect on our the dependent variable irrespective of the initial value. Okay, so this is the peculiarity of the linearity. When one unit change in x will lead to the same unit change in the dependent variable irrespective of the initial value. Okay, so OLS only deals with linear estimation and it will not deals with non-linear estimation, that you have to. Okay, so if you draw a graph for the data and if it just look like a reverse U-shaped or U-shaped, okay, then you cannot use OLS. You cannot use regressions. That's the first assumption. Second assumption is non-stochasticity of xi. What does it mean? It means that the value of the independent variable should be vary within the sample but should be fixed in the repeated sample. Okay, so from a population we are taking a samples. Okay, within the sample your x value should not be constant for all, it should be vary. Okay, but when you compare one sample value with another sample value, there the x values of the both samples should be the same. Okay, so why we are assuming these things? Okay, because when all the x values in a samples are same, okay, the x bar will also be same. Okay, so when we come to the equation of beta 1, it is sigma x minus x bar into y minus y bar, or sigma y into x. Okay, so this y and x will be equal to 0, so it will be the beta 1 will be 0 divided by 0, which is equal to 0. Okay, so we cannot estimate the beta 1 if all the values of x are equal to 1 or if all the values are 1 and same. Okay, that's why we are assuming that non-stochasticity of ui, which means that the value of xi should be vary within the sample. Okay, and third assumption is mean value of ui is equal to 0. That means average value of your u term is 0. Okay, it means that sometime, okay, the values will be the errors will be positive and sometimes the errors will be negative. Okay, but should not be but the average of this error should be 0 and there should not be any systematic tendency of this u to vary in either of the direction, positive or negative. Okay, there will be positive errors and there will be negative errors, but when you take the average it will be should be equal to 0. Okay, yes. Then the fourth assumption is, so that you can mathematically express it as a expectation of ui given xi is equal to 0. Okay, expectation of, that means average value of ui for a given particular level of income or x should be equal to 0. Okay, so you look at the graph, you can see that the average value, the conditional line or the regression line will passes through the conditional mean values. Okay, so when you compare this conditional value with other values, you can see that there are positive errors and negative errors, but the conditional value will be the exact average of these values. Okay, then this, when you take the average of this all these errors, you can see that these errors, the average errors will be equal to 0. So that's the third assumption. The fourth assumption is very important assumption, which is called the homoscedasticity assumption. Okay, so homo means equal, scedasticity means variance. Okay, so equal variance of what? Equal variance of the error term. Okay, so equal variance of the error term means what? The variance of the error terms should be a constant number for all xi. Okay, so when we estimate the variance, when we estimate the mean value should be equal to 0. That's the third assumption. But when we estimate the variance, okay, so there are different income groups, as I told you in the previous examples, 80 income groups, 100 income groups, 120 income groups. Okay, but in all these income groups there will be the variations, but the variation should be the same for all income group. Okay, so the variance of ui given xi is equal to same value, that is equal to small sigma I square. Okay, so small sigma I square is a notation to denote it as a constant value. Okay, so variance of ui given xi should be equal to a constant positive value. Okay, so how we can depict this in using the graph? You look at the first graph, x1, x2, x3. These are all different income groups or different values of xi. But if you draw a graph, if you draw a distribution, you can see that the width of the distribution are same. Okay, but when you look at the second graph, you can see that the distributions are vary in terms of the variance. Okay, in the first case, x1 case, the distribution is not that much wide. Okay, it is more peaked. Okay, but in second case it is mesocortic, but in third case it is leptocortic, or sorry, platycortic. Okay, it means that in different level of income groups, the variation among the income groups or variation in the consumption are highly varying. Okay, that should not be happen in OLS. Okay, if it is happen, then your OLS estimation will be wrong. Okay, so in reality, this will not be a case. There will be, if there are 5 different industries or 5 different firms, in all firms there will be a considerable variations. But in reality, this assumption may not be hold, and if this assumption is not holding, then there are certain problems. Okay, yes. And the fifth one is no autocorrelations. Okay, so you might have learned correlations. Okay, the correlation means what? The relationship between 2 different set of variable. What is meant by autocorrelations? Correlation within a single variables. Okay, so how we can find out the correlation within a single variable? Correlation within single variable means correlation within the different time lag. Okay, correlation between today's values and yesterday's values, correlation between the last year value and this year values, or correlation between this year value and last 5 years value. This is what we call the autocorrelations. Okay, but in OLS assumptions, the autocorrelation means what? Autocorrelation between subsequent error terms. Okay, for first y and x there will be an error, that's called u1. In the second observation there is another u2, okay, third u3, fourth u4, okay, but this u1 and u2 and u3 and u4 and u1 and u1 and u3, all these pairs, the covariance or correlation should be equal to 0. There should not be any correlation between these u1, u2, u3, u4 and all. Okay, so we can say that the subsequent error term should be uncorrelated. How we can express this in mathematically? Because using covariance we can express, because covariance is measuring the relationships. Okay, so covariance between ui and uj, ui is a one u value, uj is a next u value. Okay, given on xi and xj, so it means that ui value corresponding to xi value, okay, then uj value corresponding to xj values should be equal to 0. This is what we call covariance, no autocorrelation. Sixth assumptions, okay, no correlation between xi and ui. That means your independent variable x and your random error term ui should not have any correlations. Okay, so no covariance between your disturbance term ui or error term ui and your independent variable xi. Okay, yes, that's the 6 assumptions. And 7th assumption, okay, so the first assumption, linearity and no specification errors, was the assumptions related to the model Prf. Okay, and the third assumption, so second assumption, that means non-stochasticity of xi, okay, is related to the sample values. Okay, then the third assumption, mean value of ui, then homoscedasticity, no autocorrelation, then covariance of ui and x is 0. These are all about the assumptions related to error term. Okay, now the 7th assumption, the number of observation is n must be greater than the number of parameters to be estimated. Okay, so in a case the parameters means what? Beta 0, beta 1, something, okay, like that. Okay, so suppose there are 5 betas, beta 0, beta 1, beta 2, beta 3, beta 4. Okay, for estimating these things you need at least 6 observations. Okay, so n must be greater than the number of parameters to be estimated. Okay, that's the 7th assumptions. And the last assumption is the no perfect multicollinearity. It means that when you have more than one independent variable in your regression, that will happen only in multiple regression model. Okay, so in the multiple regression model there will be more than one independent variable, but this independent variable should not be perfectly correlated. That means the correlation should not be equal to 1 between these two independent variables. Okay, so the last assumption will be held only in the multiple regression models. Okay, so these are all the 8 assumptions of the ordinary least square assumptions. Okay, so the first one is linearity and no specification error, second one non-stochasticity, third one homoscedasticity, fourth one no autocorrelation, next one the covariance between error term and explanatory variable or independent variable is equal to 0. Okay, then n must be greater than the number of parameters to be estimated, and last one is the no perfect multicollinearity. Okay, so these are all the assumptions. If a question is being asked what are the assumptions of Euler's, then you write down first one, linearity in parameters and no specification mistakes or no specification errors, first one. Okay, the non-stochasticity of xi, second one. Third, mean value of ui is equal to 0. Fourth, no homoscedasticity, that means variance of ui is a constant number. Okay, then no autocorrelation. Okay, then no correlation between the error term and your independent variable. Then seventh one, n must be greater than the parameters, okay, to be estimated. And last one, no perfect multicollinearity. That's fine. Okay, yes. So depending upon the mark of the question, you can add the equation and certain explanations. Okay, yes. And one more thing I would like to tell you that, okay, so if all these assumptions are satisfied, then only you will get a value for your beta 0 and beta 1 that minimize your error terms, or that minimize the errors in your models. Okay, we want to get a model with a less errors, that will be only get if all these assumptions are satisfied. Okay, and if all these assumptions are satisfied, okay, and the parameters that we got, or the value that we got for beta 0 and beta 1 will have certain desirable properties. Okay, so if all these assumptions are satisfied, then our estimators will have certain desirable properties. Okay, and these desirable properties are summarized by Gauss and Markov in their theorem called blue. Okay, so if all these assumptions are satisfied, then the estimators will be blue. Blue means what? The estimators will be best, linear and unbiased. Okay, so if all the assumptions of OLS are satisfied, then the estimators thus obtained will be best, linear, unbiased. This is what we called Gauss-Markov theorem. Is it okay? So if a question is asked, what is the Gauss-Markov theorem or what is blue, you have to write that Gauss under the assumptions of OLS, or if all the assumptions of OLS are satisfied, then the estimators obtained will be best, linear and unbiased. Okay, so what is best? Sorry, what is linearity? Linearity means the OLS coefficient beta 1, that means the slope coefficient can be expressed in terms of the samples values of y. Okay, you just remember that, you just mug up that linearity means the OLS coefficient beta 1 can be written as a linear function of the sample values of y. Okay, I am not going for the derivation and all, you just mug up this. Okay, then what is the unbiasedness? The OLS coefficient beta 0 is unbiased. OLS coefficient beta 1 is also unbiased. What is unbiased means? Your sample estimator beta cap 1 and the population parameter beta 1 should be equal to same value, or the difference between the beta cap and beta should be equal to 0 or will be equal to 0. That is the unbiasedness. Okay, then what is the variance? The third one is the minimum variance. Okay, it means that the variance of the beta 0 and the variance of beta 1 should be minimum or will be minimum. Okay, then the fourth one is the consistency. That means whenever you increase the sample size, your parameters or the statistics will be approached to the parameter. That means your sample estimator will be approached to the, or will be equal to the your population parameter or your Prf parameters. Okay, when you increase the sample size, your SRS will be approached to the Prf. Okay, so that is all about these properties of the OLS. So under the assumptions of A1 to A8, that means if all the assumptions of OLS are satisfied, then the estimated then obtained will be best, linear, unbiased. Okay, so in this, what is meant by best means? Best means unbiasedness plus minimum variance. Okay, so if both are satisfied, then we call it as a best. So best linear unbiased. Okay, so this is what we called Gauss-Markov theorem or properties of OLS or blue. Okay, once again I'm repeating that if assumptions of OLS are satisfied. Okay, so if all the 8 assumptions discussed is satisfied, then the OLS estimators obtained will be best. Okay, will be linear and will have minimum variance, and apart from this, in large sample it will be asymptotically efficient, or you can say that it is consistent. Okay, so this is what we call the best or blue or best linear unbiased, or what we call the Gauss-Markov theorem. Okay, so this is what about the assumptions and properties of the OLS. Is it okay? Yes. So thank you. Hello, welcome to one more sessions on econometrics. Okay, so in this we will discuss how to test or how to do or how to evaluate a regression results, or how to evaluate the parameters of a regression that we have obtained through OLS method. Okay, so in last class we have discussed the normality assumptions. Okay, so in order to go further in all our evaluations, we assume that the normality of the distribution, okay, or the underlying distribution is normally distributed. Okay, then when we say that the normality distribution or the underlying distribution or the beta cap 1 and beta cap 2 is normal distributed with mean and variance. Okay, and we know that the mean of u is 0, so ui is a NID of 0 and variance, and we know that this ui, the mean of this ui is always equal to 0. Okay, but the variance is not 0 but a constant. Okay, then how we can find out the variance? We have said that when we discuss about these properties, we have said that the variance should be minimum. Okay, but how we can find out the variance? Okay, so that we will see in this video, in this first part of this video, and remaining part we will discuss some of the hypothesis testing procedure about various statistics which we have derived from the regression model. Okay, so variance is basically used to measure the reliability of accuracy of an estimator. So reliability, accuracy. Okay, in order to measure the reliability and accuracy of a estimator, we usually used to adopt or apply the variance test or standard error test, or together this variance and standard error is known as statistical test. Okay, then in statistics, as I told you, the reliability is always checked by variance or its square root or standard deviation or standard error. Okay, so variance of beta cap 1 means what? Small sigma divided by sigma small x square. Okay, then its standard error is small sigma divided by root of sigma small x square. Then what is the small sigma? Small sigma is nothing but root of sigma u cap square or RSS divided by n minus 2. Okay, small sigma is equal to, small sigma is nothing but the standard error of the regression model. Okay, it is nothing but the RSS divided by n minus 2. N minus k. K means 2 variable. Okay, so since we are dealing with 2 variables, so k is 2. So n minus 2. Root of RSS divided by n minus 2. Okay, so with this information, it is very easy to calculate this variance of beta cap 1. Then how we can find out the variance of beta cap 0? For that, we have to find small sigma square, okay, into sigma capital X square divided by n into sigma small x square. If you take the root of this, you will get standard error. Okay, so the thing is that the variance and standard error should be minimum as possible. If it is 0, then it will be highly precise even though it is not possible. Okay, so using in order to test the accuracy of a OLS estimator or a regression coefficient, we usually use to test using a standard error and variance. If the variance is very close to 0, then it is fine. Okay, yes. Then after this, after checking this reliability, okay, we have to test whether our slope coefficient is significantly different from 0 or not, or we have to do certain hypothesis testing about our interest. Okay, so in simple regression model, we usually do a test called t-test. Okay, so before going for this t-test, we have to specify the tail of the test. How we can specify the tail of the test? The tail of the test is based on how we can determine whether a test is one tail or two tail. It is based on the simple in alternative hypothesis. Okay, look at the symbol in alternate hypothesis. It is not equal to, then it means that two-tail test. If it is less than or greater than, it means that it is a one-tail test. If it is greater than, it is a right-tail test. If it is less than, it is left-tail test. Okay, so it means that in our previous example about consumption and income, what we have assumed, consumption and income are related. Okay, that means there is relationship between consumption and income, and there is no relationship between consumption and income. Okay, so in hypothesis, what we usually do is, okay, we will assume a value, or we'll assume a null hypothesis in which it is assumed to be true in the beginning of the analysis. Okay, so a null hypothesis is a hypothesis that is believed to be true until it declared as false. So what we have to do, we have to assume that this beta 0 and beta 1, sorry, this x and y are not related. So our null hypothesis will be beta is equal to 0. And alternative hypothesis, beta is not is equal to 0. It means that there is a relationship. Okay, yes. Then based on our theoretical things, we can change this specification into greater than or equal to, or less than or equal to, whatever it may be. Okay, so I'm not going for that. So after this, what we have to do is, we have to find out the t-test or t-value. How we can find out t-value? In regression, t-value means what? T means beta cap divided by, beta cap 1 divided by, or beta cap 0 divided by standard error of betas. That means if you want to find out the t of beta 0, then it means that your beta 0 value divided by your standard error of your beta 0. Okay, then, or if it is beta cap 1, then beta cap 1 divided by standard error of beta cap 1. This is the t-test or t-value. Okay, then its table value you can find out from any of the table, any of the t tables. Okay, or you can find out from the some of the softwares, and then you can compare. If actual t value is greater than the table value, you reject the null hypothesis. Okay, so this is the hypothesis about the t-test. Okay, so t-test is used to test the individual significance of the parameters beta cap 0 individually and beta cap 1 individually, separate. Okay, then if you want, in multiple regression model there may be more than 2 or 3 independent variable. There you can check the significance level jointly. For that you have to use F test. Okay, yes. Then you can also use confidence interval test, that I'm not going to discuss with you, okay, because that's not so important. Or you can use p-value approach. Okay, so what's p-value? P-value is the smallest level of significance at which a null hypothesis can be rejected. Okay, so this is basically the probability of committing a type 1 error. Okay, so it's also you can find out from using its equations. Okay, so I'm not going for that too. Next, the very important thing is the goodness of fit of the model. How we can find out the goodness of fit of the model? Okay, whether the fitted model is good or bad, how we can test it? Okay, so as you know that the aim of the regression analysis is to explain the behavior of the dependent variable in terms of independent variables. Okay, so the total variations in independent variable may be due to the variations in x or maybe variations in error terms. Okay, so you can say that some variations in y can be explained by the regression, and some variations in y cannot be explained by the regression. It is explained by the residual sum square. Okay, so the coefficient of determination or goodness of fit or r square, okay, it is a most commonly used measure of goodness of fit of the model, or how well our sample fit the regression line. Okay, so the r square is just basically how much proportion of the total sum square is explained by the regression line, or how much percentage of the total variations in dependent variable are explained by the independent variable or that the measured regression line. Okay, so its equation is r square is equal to sigma y cap minus y bar square divided by sigma yi minus y bar square. Okay, so the sigma y cap minus y bar square is called ESS, and sigma y minus y bar square is called RSS. Sorry, TSS. Okay, so if you find out sigma y minus y bar square, it is TSS, total sum square or total variations in the dependent variables. Okay, then after finding out the y cap, you just subtract y bar from each y cap and square it. It is known as ESS. Okay, then r square is nothing but the ESS divided by TSS. Okay, or ratio of the explained sum square to total sum square. Okay, or you can find using the RSS also. That means sigma u cap square divided by 1 minus sigma u cap square divided by sigma y minus y bar square, or 1 minus RSS divided by TSS. Okay, it is nothing but if the total variations is in 100%, okay, the regression line can only explain the 80%, then remaining 20% is explained by the other factors. So RSS is in total 100%, only 80% are explained. Okay, so the value of RSS will be 0.8. Okay, or 1 minus 20 divided by 100, it is also 0.8. Okay, so a value for r square, or a value that value beta cap 0 and beta cap 1 that minimize the RSS will be automatically maximize the ESS. Sorry, maximize the R square. Okay, so since the measuring the R square is based on the RSS, okay, a beta cap 0, a beta cap 1, the value of the estimators that will minimize the errors. Okay, so that value will automatically maximize the R square. Okay, and this R square value is non-negatives. It can be 0, it can be 1, or it can be in between 0 and 1, but it will be never become negative. Okay, and the R square value is always lies in between 0 to 1. 0 means perfect, 1 means perfect fit, and 0 means what? No any single percentage of variations in dependent variable are not explained by this, or cannot be explained by these independent variables. Okay, yes. So that's all about the R square. So R square is a measure of goodness of fit of the model. It will tell us how well the sample fit the regression line. How we can find out? It is finding out using total variations, estimated variation, or from RSS, or residual sum squares. Okay, so it means that total deviations in dependent variable is a sum of the estimated sum square plus RSS, residual sum square. Okay, then R square is ESS divided by TSS, or 1 minus RSS divided by TSS. Is it okay? Yes. Now, in your syllabus, one more part is there, that is the multiple regression. Okay, so in simple regression, as I told you, there will be only two variable, one independent variable and one dependent variable. Okay, but the thing is that in practically many situation, we may not be able to explain the dependent variable using one single variable. So what we have to do, we have to include many other variables. Okay, so if there are more than one variable or more than one independent variable, it is known as multiple regression model. A multiple regression model is a regression model where there are more than one independent variable. Okay, so the most important case of a multiple regression model is three variable model. Okay, one dependent variable and a two independent variable. Okay, and the thing is that when we have more than three variables, okay, then it is very difficult to find out the parameters or beta 0, beta 1 or estimators using the calculator or using the Excel or using some other pen and notebooks and all. Okay, so it will be very difficult. You look at, assume that there are three variable y, x1 and x2. X1 and x2 are independent variable. How you can find out the value for these? Beta cap 1 means sigma x1 y sigma x into x sigma x2 square minus sigma x2 y into sigma x1 x2 divided by sigma x1 square into sigma x2 square minus sigma x1 x2 whole square. So this is a very big equation. Okay, similarly you can find out the value for beta cap 2, and also if you subtract these both equations, multiply with its independent with its x1 bar and x2 bar from y bar, you will get these intercept also. Okay, but the thing is that doing this operation or doing multiple regression manually is very difficult. Okay, so I'm not going for that. You understand that this is the equation for the estimator in a multiple regression model, and multiple regression model was first used by R. Benini. He was an Italian statistician in 1990. Okay, yes. So all other things will be remain just like the simple regression model. Okay, hypothesis testing and everything will be depends on will be similar to the simple regression model. But thing is that only one thing will be different. That's interpretation. Okay, in multiple regression, when we interpret one slope coefficient, we have to keep the other coefficient as the constant. Okay, for example, if consumption depends on income and wealth, okay, then where consumption income coefficient is 0.5 and wealth coefficient is 0.25, then we can interpret it as a, if 1 unit of income increase, okay, the consumption will be increased by 0.5 unit, keeping the effect of wealth as constant. Similarly, when the wealth is increased by 1 unit, okay, the consumption will be increased by 0.25 unit, keeping the effect of his income as constant. Okay, so in multiple regression model, the slope parameters are known as partial coefficient or partial slope coefficients or partial elasticities. Okay, yes. Similarly, all other things, precision of the model or variance, standard error, hypothesis testing, and everything will be the same except t-test. Okay, here we can also test the individual coefficient using t-test, and also we can test the joint significance using f-test. Okay, and when we come to the goodness of it, in multiple regression model, we won't use the R square because R square is a non-decreasing function of your independent variable. That means if you increase the independent variable number, then your R square will be automatically increased. So what you have to do, you have to adjust your ESS and TSS or RSS and TSS with degrees of freedom. That means n minus k and n minus 1. Okay, so if you adjust your r square with degrees of freedom both in numerator and denominator, it is known as the adjusted r square or alternative coefficient of determination. Okay, so that's all about the multiple regression model. Okay, so in the session on econometrics, we have discussed what is econometrics, the methodology of econometrics. In that we have discussed in detail what is the econometric model. Okay, then we discussed what is regression and how it is different from correlations, what is conditional mean and unconditional mean, what is PRF and SRF, and what is the objective of the regression, what is OLS, how to derive the OLS estimators, how to estimate the, how to find out the value for this beta 0 and beta cap 1 using examples. Okay, then we have seen the assumptions of OLS, the properties of the OLS, then we have seen the normality, the test for the normality, then we have seen the testing the precision or the accuracy of an estimator. Okay, then we have seen checking the doing hypothesis testing, especially t-test and f-test. Then we have seen the p-value approach. Okay, then goodness of fit of the model or r square, or and multiple regression, then multiple r square and multiple adjusted r square. Okay, so I hope that I have discussed everything about each and everything in detail about or from the topics that are in the syllabus. Okay, then after these things there is a topic testing for some linearity, something like that. Okay, so it is nothing but testing for linear means, or the method for linear means correlation and regressions. Okay, so this correlation and regression are the two powerful method to test the linear associations between certain variable. If you want to test the direction and the degree, you can go for correlation, or if you want to test the cause and effect relationship, you can go for the regressions. Okay, so I hope you have enjoyed the class, and if you have any doubts, you can personally contact me, okay, or you can contact the Alches. And I wish all the best success, okay. Yes. And I would like to suggest you that if you have not mathematically very powerful, very knowledgeable person, don't go for this equation and all. You just understand the concept and you prepare a small note, okay, descriptively, okay. That will help you out in answering the questions properly, since the questions are in descriptive mode, okay. Then you have to answer the thing in very short way, okay. So you prepare your own note using this my class and my presentations, okay. So once again, I wish all the best success for your exam and future career, okay. Thank you very much. Hi everyone, welcome to one more classes on econometrics. In your syllabus, after the estimation part, there is a topic called normality of distribution and how to test the normality using descriptive statistics. Okay, so in this video we will discuss what is this normality is and why we are assuming the normality and how to test this normality. Okay, so uh, so far in the couple of previous classes we have discussed the how to find out the value for beta cap 0 and beta cap 1, okay. So this part is known as the estimation part, okay. But the classical statistical inference consists of both estimation as well as hypothesis testing, okay. So we have covered the estimation part already, and we have already seen that under the assumptions of classical regression model, okay, the parameters or the estimators beta cap 0 and beta cap 1 possess certain desirable properties, and these properties are contained in the well-known Gauss-Markov theorem or blue properties or blue theorems, okay. And you have to understand one thing: this beta cap 0 and beta cap 1 are random variable, because whenever you change the sample, your beta cap 0 and beta cap 1 will also changes. For example, in our previous example, we have the population was 60 families, okay. So we have selected 10 families and we have got one value for this beta cap 0 and one value for beta cap 1. If we change the samples, if you increase the sample or if you remove some number from this and if you add a new numbers, you will get a new beta cap 0 and new beta cap 1. It means that whenever you change the sample, your beta cap 0 and your beta cap 1 or your estimators will also changes. And because of this thing, we call the estimators the random variable, okay. And in regression analysis, our aim was not only to estimate the SRF but also to infer about the PRF. There are two steps. First you find out the SRF, then you assign this SRF value to PRF, okay. So the most important step is to infer about the PRF from SRF, okay. So in order to infer about PRF, or in order to find out, in order to do certain hypothesis testing about PRF, we need to find out the probability distribution of estimators beta cap 0 and beta cap 1, okay. Yes. Then the probability distribution of these estimators will be depends on the assumption about the population, the probability distribution of UI. And knowing the distribution of UI is very important, okay. So what I'm saying that the probability distribution of beta cap 1 and beta cap 0 is depends on the probability distribution of u. Okay, and the OLS does not make any assumptions about the probabilistic distribution of UI. So we have seen many assumptions. In that assumption, we didn't see an assumption regarding the normality or assumption regarding the distribution of UI. Okay, but in regression context, it is usually assumed that UI follows, that error term follows a normal distribution because of two important reasons. Okay, the first reason is that UI is mainly a variable that influence, or is a variable that included the effect of omitted or neglected variable. UI means all the variable that we have neglected from the model, or that we have removed from the model. Okay, and we assume that the neglected variable's impact on the dependent variable is very, very small. Okay, because we assume that sigma u cap square is minimum. Okay, so using the celebrated central limit theorem in statistics, we can show that if there are large number of independent and identically distributed random variables, the distribution of their sums or totals tend to be also normally distributed. Okay, so assume that in our consumption example, consumption depends on income. There are some other factors like wealth, number of family members, living area of the family, okay, number of earning members. So we are removing all these variable, and instead of this variable we are just putting a u. Okay, so this u contains a lots of independent variables. Okay, so in total the effects of all these, the sum of these all independent variables will be normally distributed as per the theoretical founding of, or theoretical what we call suggestion by the central limit theorem. Or as per central limit theorem, if there are large number of independent variables, then their sums will be normally distributed. Okay, so CLT or central limit theorem provides a theoretical justification for the assumptions of normality. That's the first thing. And second thing is, when we take the normal distribution, there is a property. The property is that any linear function of a normally distributed variable is itself normally distributed. Any normally distributed variables is itself, any linear function of a normal distributed variable is itself normally distributed. Okay, and you know that OLS estimators beta cap 0 and beta cap 1 are linear function of UI. Therefore, if UI are normally distributed, then beta cap 0 and beta cap 1 is also normally distributed. Okay, so because of these two important theoretical justifications, what we are assuming that UI is normally distributed, and because of the UI is normally distributed, beta cap 0 and beta cap 1 is also normally distributed. Okay, so apart from this, there are a lots of theoretical justification for the adoption of the normal distribution, or for the assumption of this normality. Okay, I am not going for that because these are the two important things. Now, with this normality assumption of beta cap 0, normality assumption, the classical regression model turned to as a rename as a classical normal linear regression model. Okay, so without this normality assumption, we usually say that it is the regression model is classical linear regression model. Okay, but when we include the normality assumption, then our regression will be renamed as classical linear classical normal linear regression model, CLNRM. Okay, which assume that UI is distributed normally and independently with average value of UI is equal to 0, variance of UI is equal to constant number, and covariance of UI and Uj is equal to 0. That means, as you know, that if there is a distribution, then it will be distributed independently and identically with its mean and variance. Okay, but here the mean is equal to is 0 and the variance is equal to small sigma square. Okay. So we can say that the U term, the error term is normally and independently distributed, NID, it is usually called NID, with a mean 0 and a variance small sigma square. Okay, so this is about the normality of here. So what we are doing is that we have to find out in order to do certain hypothesis testing about beta cap 0 and beta cap 1, we need to find out the probability distribution. Okay, so we cannot derive a probability distribution from for this beta cap 0 and beta cap 1. Its distribution is derived from the distribution of UI, and distribution of UI is normally distributed, so the distribution of beta cap 0 and beta cap 1 is also normally distributed. And how we can test it? In your syllabus it says that, or the syllabus, the topic is how to test the normality using descriptive statistics. Okay, but in econometrics we usually do not test this normality using the ordinary descriptive statistics. We usually refer for certain advanced method. Okay, but in your syllabus it asks that how to test this normality using descriptive statistics. So let me tell you that. Okay, so a normality test is basically used to determine whether the sample that we have derived from a population is normally distributed, or the sample that we have taken from a population, that population is a normally distributed population or not. Okay, so it can be tested using different ways. Using graph we can test. How we can test using graph? You can just plot this data in a XY plane or in a histogram and look at this, how the histograms look like. Okay, so in the case of the first graph, you can see that it is normal distributed, because in this distribution mean, median and mode will be equals. Okay, whereas if mean, median and mode are unequal, then we will have a unequal distribution or a symmetric distributions. Okay, yes, that's the way we can find out the normality using graph, symbol graph. Okay, then if you go to advanced graph, then you can see that there is one more test called QQ plot or quantile in quantile plot. Okay, so I'm not going for the details. Okay, you can just simply write this if the question is asked. Then there are certain tests which is based on certain descriptive statistics. Okay, the first one is back of the envelope test. Okay, so using this test, how this test is working, you know, it takes the maximum and minimum values and compute their z-score or t-statistics. Okay, number of sample standard deviation that a sample is above or below the sample mean. We take the sample mean and we'll compare how many samples are, or how many sample standard deviation are below and above the sample mean. Okay, and it compare with the 68, 95 and 99.7 empirical rule. You might have learned there is an empirical rule in normal distribution. Okay, then that means mean plus one standard deviation will cover 68% of the total area. Mean plus 2 standard deviation will cover 95% of the total area under the normal curve, and mean plus or minus this 3 standard deviation will cover almost 99.7% of the total area. Okay, so using this criteria, you can compare this with your Z scores and you can arrive at a decisions. Okay, or most importantly, a most popular thing is that we can get the information about the normality using third and fourth standardized moment test, or this is known as Pearson gamma coefficients. Okay, so it is nothing but we are comparing, or we are finding out the skewness and kurtosis based on third and fourth standardized moment. How we can do that? Okay, I hope that you know how to find out the moment. Okay, then with that knowledge, I am keeping that in mind, then gamma 1 is equal to root beta 1, where beta 1 is equal to third moment square divided by second moment square. Okay, then gamma 2 is basically the kurtosis. It is equal to beta 2 minus 3, then beta 2 is equal to fourth moment divided by second moment square. Okay, then if the coefficient of this gamma 1 is equal to 0, then and the gamma 2 coefficient is plus 3, then you will have a mesocortic curve or exactly normal curve. Okay, and if your gamma 1 is equal to 0 and your gamma 2 is there are some other other values other than 3, plus 3, above this 3 and below this 3, okay, then still you have the normal distribution curve, but the shape of the normal distribution curve will not be exact normal, or it will be certain time it will be leptokurtic, or it will be a platykurtic curve. Okay, so this way we can use the descriptive statistics to find out the normality test or normality. And apart from these, there are certain tests based on frequentist statistics like Jacob-Barrett test, Shapiro-Wilk test, and Pearson chi-square test. Okay, and if you are very familiar, if you are doing any research and all, then you will be knowing these tests. Okay, so in econometrics, we usually test the normality using Jacob-Barrett test. Okay, so we will assume certain thing about normality, and on the basis of certain statistics we test it. Okay, then the advanced Bayesian statistics methods are there, like Kullback and Libler divergence method. Okay, so these are all certain methods to find out whether the underlying population from which the sample is drawn is normally distributed or not. Okay, yes, so that's all about, yes, so that's all about the normality test. Okay, so I hope you understood what is normality. Here in regression, we are, normality means what? Normality of the estimator beta cap 0 and beta cap 1. Okay, it is normally distributed because UI is normally distributed. How UI is normally distributed? On the basis of central limit theorem. Okay, and since central limit theorem is assumed that large independent variable and their sum will be always normally distributed. Okay, then from the property of the normal distribution itself, we can say that beta cap 0 and beta cap 1 will also normally distributed. Okay, and we can test it using graphical method, or simple descriptive statistics, or frequentist method, or Bayesian method. Okay, so I hope that you understood what is normality and how to test it. Okay, thank you. Hello, welcome back to the channel of Economics, a platform that exclusively discusses economics and econometrics. Today, what I am going to show you how we can do the regression analysis using Excel manually, that means without using any data analysis toolpack. How we can derive the OLS or regression coefficients, then how we can find out the standard error variances, then t-value, the probability values, confidence interval, and all such things. That means all estimation methods and evaluation methods associated with a two variable or simple regression model. Okay, so assume that we have a two variable y and x. As you know that this y is a function of x. Y is a function of x. Okay, so here we are having the total number of observation is equal to count. Click it here. Yes, we have total observation is 10, and our equation is y is a function of x, y is the dependent variable and x is the independent variable. Okay, yes. So this can be the regression is assumed that regression equation is linear in parameter. Okay, so this functional form we can convert into a linear equation, just like y is equal to b0 plus b1 x. Okay, yes. So in econometrics, so this is just a functional form. This is linear form. Okay, then if we add a term y is equal to beta 0 plus beta 1 x plus u, okay, then this is known as stochastic specification of linear regression model. Okay, so our regression model is just like this. It shows that y is depends on x and some other values. Okay, the error term will capture all other omitted variable or omitted values or omitted variables from the model. Okay, that exclusive that will influence y, but we are not including in our model explicitly. Okay, yes. So in regression, what's our aim? Aim of the regression is find out the value for beta 0 and beta 1. Okay, look at the values, look at the variable parameter I have written, capital beta 0 and capital beta 1. Okay, so why I am putting beta 0 means it indicates population. Okay, so assume that there are 1,000 populations. Okay, 1,000 members are there in the populations. Okay, so from 1,000 members, okay, if we find out the value for beta parameters, okay, so that is beta 0 and beta 1, it will be our population parameter. Okay, but we have only 10 sample values taken from these 1,000 values. Okay, so what we have to do, we don't have information about these things, but we are only able to calculate small beta 0 and small beta 1, and this small beta 1 is beta 0 and beta 1 are sample statistic. Okay, yes. So our aim is what? Estimate beta 0 and beta 1 on the basis of beta 0 and beta 1. Our aim is to find out this value. Okay, but we are not able to do that because we don't have that much data. We are having only 10 observations, so we can only estimate this small beta 0 and small beta 1. Okay, so we estimate small beta 0 and small beta 1, and on the basis of the small beta 0 and small beta 1, we will infer what is this capital beta 0 and capital, or what is the parameter on the basis of what is statistic. Okay, on the basis of statistic, we are inferring what is the parameter. Is it okay? So that is the aim of the regressions. Okay, so when we do that, okay, so what we do is there will be changes in y. Okay, then changes in x is also there. You look at this data, y is changing for y values are different for different individuals. Okay, this is also different for different. Okay, you assume that y is the consumption and x is the income. Okay, yes, so consumption depends on income. Okay, so what's our aim of the regression? We have to find out changes in consumption, okay, and you look at there's a changes in income is also there. Okay, okay, so our aim is what? We have to estimate the changes in consumption when there is a changes in income. That means when there is a changes in income, how much percentage changes will be there in the consumptions. So that is the major aim of the finding the regressions. Okay, so how we can find out the changes in consumption due to changes in income? It's nothing but the slope values. Okay, so in this model, if you look at this model, there are two parameter. One is intercept, it is beta 0, and one is slope value, it is beta 1. Okay, this slope beta 1 or slope coefficient beta 1 tell us changes in consumption due to changes in income. Okay, or changes in y due to changes in x. Okay, then what is beta 0 will give us? It will tell us what will be the value of y when x is equal to 0. What will be the value of y when x is equal to 0? Okay, so this is what is the major aim of the regression analysis. Okay, yes, so finding out this beta 0 and beta 1 is the major role of the regression in statistical estimation or econometric estimations. Okay, but we have to find out, so when we will get a better value for beta 0 and beta 1, when we will get a better value for beta 0 and beta 1, we will get a better value for beta 0 and beta 1 when the effect of all other terms is minimum. Okay, so that means in this equation we are having a deterministic term and stochastic term. Beta 0 plus beta 1 x is the deterministic part. Okay, then u is the stochastic part. Okay, so we can able to explain the changes in y using changes in x only when our error term is minimum. Okay, so our main idea is to convert, or what we have to say, main aim of the regression is to reduce, to find out the value for beta 0 beta 1 by minimizing the error. Okay, yes, So how we can find out the value for this? Okay, so let me check you how we can find out the value for, yes. Okay, so first thing what we have to do is we have to find out the value for beta 0 and beta 1. Okay, so what is the equation for that? Beta 0 is equal to sigma, I am putting E for sigma, sigma xy divided by sigma x square. Okay, so what is beta 1? Beta 1 is y bar minus beta cap 1. Okay, beta cap 1 means estimated value of beta 1. Y bar minus beta cap 1 into x bar. So finding out this value is the major role of the regressionist. Okay, how we can find out that we have to check. Okay, so you have to understand this. In this equation, we are just in this first equation, slope equation, we are just putting small x and small y. Okay, so small x is equal to what? X minus x bar. Then small y is equal to what? Y minus y bar. Okay, yes. So how we can find out it? Yes, for that what you have to do is you have to find out the average first. Okay, so find out the average of y is 115. Okay, you put the cursor here and just drag to here, then you will get the x or average value of x. Okay, we have got 115 and we have got, yes, 170. Okay, now what you have to do is you find out small y and small x. You find small y and small x. Okay, how we can find out small y? This 55 minus this 115. Okay, so you do that one, you get minus 60. Okay, then if you drag it, you won't get the values, you will get the errors, because we are no the same value is repeating here. So why it has happened, so this is the mistakes, I'm just undoing it. The thing is that these y values are changing, but the x bar is x bar is not changing, it is constant. Okay, so whenever you put a constant value in Excel, you have to tell to Excel that this value is constant. So I am just, for that what we have to do is we have to put a dollar symbol. Okay, so dollar symbol means that this value is a constant value. Then you just click it, now you drag it, then you will get this values. Okay, yes. Now after that you just drag to this area, then you will get the x values also. Okay, no need to do the, no need to repeat the same things again, you can just drag to the right side, then you will get the small x also. Okay, then if you find out the sum of these things, you will get 0 always, because it is due to the first properties of the arithmetic mean. That means sigma x minus x bar is always is equal to 0. Okay, yes. Then what we have to do is you have to find out the y into x. Okay, for that what we have to do is this is y multiply with this x. Okay, yes, we have got y into x. Then what's next? Yes, x square, small x square, this is the small x. That means in regression equation we are squaring the deviation of the independent variable, not the dependent variable. Okay, so the denominator is always an independent variable. Okay, so this is just square it For squaring, you can put the cap symbol, okay, which is there on the number 6. Okay, you square it, you got these values. You will get these values. Okay, yes. Then what you have to do is you have to sum these values and you sum these values also. Okay, now you got the equations. Okay, so this is what is equal to, this is sigma x into y means 80,920 divided by this 33,000, 0.7333 something like that. Okay, then next is what we can find out the beta 1. Sorry, this is beta, yeah, so this is beta 1 and this is beta 0. Okay, yes. So this is 0.573, and you have to remember that first we will get the slope parameters. If you got the slope parameters, then only you will get the index of parameters. Okay, so this is equal to y bar. What is the y bar? 115 is the y bar minus this is your estimated beta cap 1 value or beta 1 value into your x bar. Okay, we have got 17.533. Okay, so we have estimated the value for beta 0 and beta 1. Okay, so this is what we call the regression analysis. Okay, yes. Then how we can interpret this? It tells us that, okay, whenever your income increase by 1 unit, income is always measured in terms of rupee or dollar. Okay, so whenever your income increased by $1, your consumption will be increased by $0.57. Okay, then if there is no income for a person, then he has to get at least $70.5 to spend for his necessary purposes. Okay, so this is the way we can find out the oilless estimators. Is it okay? Yes. Now, uh, let me calculate the y cap for all pupils or all observation. What is y cap? Y cap is nothing but the estimated equation for a particular observation. Okay, that means look at the equations. Okay, we have got alpha beta 0 plus beta 1 into this particular x corresponding to the 55. Okay, so the 63, and you have to remember that this beta 0 and this is beta 1 are constant. Okay, so you have to put the dollar symbol, then only if you drag this value you will get the values, correct values. Okay, so we have got y cap. What does it mean? It means that for this fellow 55, his income was 55. Okay, so his consumption was 55, but when we estimate the regression model we have got 63. When we estimate the model we have got 53, but his actual consumption was 55. Okay, but you have to remember that in regression model we are always measuring the average consumptions for a group of people. Okay, so we will not consider the individual uh, estimates. Okay, so his consumption is 55, but when we estimate this model, that means when we uh, substitute the betas b0 and b1 in equation, okay, and by multiplying with independent variable we have got a value, that value is known as estimated y. Okay, so this is our actual y and this is our estimated y. Is it okay? Yes. Now this is y cap and this is y and this is y cap. Okay, but you can see that y and y cap we can see the differences. Okay, So the difference between y and y cap is known as u cap. Okay, so difference between y and y cap is known as the errors. Okay, so in first case, what is the error? Okay, this is the actual value, but we have estimated, we have overestimated. So there is a mistake, there is an error of minus 8.4. You drag it for all. Okay, so we have got positive errors and negative errors. Okay, so this is what we call positive errors and negative errors. Okay, but if you sum this error, you will always get 0. Okay, so in Excel, if there is if you after the calculation, if the value or if the letter is coming, then it means that it is 0.0000 something. Okay, so how we will get this value, exact value? You click this value, then you just format this values or format this column or format the cell with number. Okay, then you will get 0. Okay, so if there is 0, if there is e appearing, then you have to understand that it is 0.0000 something like that. Okay, and how we can convert into actual values? Okay, you right click, okay, format the cell for number, then you will get the value. Okay, so we have got u. Okay, so here you have to understand one thing. Okay, so in our main idea was to reduce the errors. Okay, but if you take any values for this y and x, okay, this error sum or sum of the errors will be always equal to 0 because, okay, because of this property, because of the first property of the arithmetic mean. There will be positive values and there will be negative values. Positive values will be exactly balanced or offset by the negative values. So sum will be always equal to 0. Okay. So in regression model, our aim is to reduce the errors. Okay. But when we adopt a criteria of sigma u or sum of the errors, that will be always equal to 0. So what we have to do? So we cannot adopt this criteria. Okay, so in order to overcome this criteria, we have to adopt another criteria called the sigma u cap square. Okay, so in order to overcome this issue with the sum is 0, what we have to do is you multiply this you square this u cap. Okay, you just square it. Minus 8.4 square is 70.56. Okay, then you do for all. Okay, then you submit. Yes, we have got 1046. 1046. Okay, so what does it mean? 1046. It means that the squared errors, the sum of the squared error is 10.46. Okay, and our in regression model, our aim is to reduce the squared error terms, or this is what we call the RSS, residual sum square, residual sum square. Okay, then this residual sum square will be always minimum. Okay, this RSS is always minimum when we do the OLS. Okay, so that's the advantages of this OLS. That means there are there are different assumptions for OLS. If the assumptions are true, then this RSS will be minimum. That is one of the main advantages of this OLS method. Okay, yes. Now what I'm going to tell you is, now we have completed the analysis, or we have completed the regression models. Okay, We have find out this beta 0, beta 1 values, then we have find out the RSS. Okay. Now what we have to do is we have to find out the R square. Okay. So R square is means nothing but goodness of fit of the model. That means how much percentage of the variations in Y are explained by this X. Okay. So it is there are for a Y is a function of X and U. Okay. That means Y is equal to X plus U. Okay, that means there are deterministic part and stochastic part. Okay, so how much variations in Y are explained by X, and how many variations in Y are not explained by this X, that we have to find out. Okay, yes, that means if almost all the variations in Y are explained by X, then the goodness of fit of the model is good. Okay, or if the variations in Y are not explained by X, then it means that other variable or other variables that are not included in the model are explained in the variations in Y more. Okay, yes. So how we can find out that? For that, there is an equation. Equation is that ESS divided by TSS. Okay, or 1 minus RSS divided by TSS. Okay, both are the same. R square, this is also R square. 1 minus RSS divided by TSS. Okay, RSS we have found. Okay, then what is this ESS? ESS means estimated sum square. Estimated sum square. Okay, that means it is sigma y minus it is mean by sigma y minus sigma y cap minus y bar square. Okay, then what is TSS? TSS equal to sigma y minus y bar square. Okay, so let me find out the ESS first, or let me find out the TSS first. Okay, so this is the small y. Okay, that means small y means what? Sigma y minus y bar. Okay, so you just square it. This is y square. You do it for all. Okay, then you submit. Yes, you have got 11,8994. Okay, so this is your TSS, total sum of squares, or total deviation, or deviation in dependent variable from its average. Okay, yes. Then this is y, yeah, this is y square. Okay, now y cap square, small y cap square. Okay, not capital Y cap square, small y cap square. Okay, so this is our y cap. Okay, so before that, let me tell you one more thing. If you find out the average of the y cap, okay, that will be equal to this. Y bar and y cap bar will be always one and the same. Okay, so what we have to do, you can take y cap, this is y cap minus y bar or y cap bar. Okay, then you square it. Then do it for all. Then you submit. Then we have got 1000. Yeah, 1000. Sorry, 10,847 is equal to 1,847. Okay. Then what is RSS? I have told you this ESS divided by TSS. Okay, how much? 0.9120. Then what does it mean? It tells that 91% of the variations in Y are explained by the X, and almost 9% of the variations in X are not explained by this X, and it is explained by some other factor. There are some other factors that are explaining 9% of the variations in Y. Okay, then you can alternatively you can use the other equations. What is that? 1 minus RSS, this is RSS divided by TSS. Okay, so both will give you the one and the same answer. Okay, so this is the way how we can find out the goodness of fit of the model. Is it okay? Yes. Now what we have to do is, after finding out these things, next idea is we have to find out the variance. Okay, variance of beta 0 and variance of beta 1. Why we need to find out the variance? Because variance will measure how much variations will be there in these parameters when you change the sample. Okay, so we had a sample of 10,000, so we had a population of 10,000. From 10,000 we have taken only 10 samples. Okay, then we have got 0.573 and 17.53. If you take some other 10 samples, other sample with 10 observation, you may get some other value for beta 0 and beta 1. Okay, then if you take another one, you will get some other values. Okay, but our assumption is that the variances among these estimators should be minimum as possible. The variance should be minimum as possible. Okay, so how we can find out this variance of beta 0 and beta 1? It is very simple. Okay, so for that what we have to do is we have to find out there's an equation is this is the equation for that, small sigma divided by sigma small x square. Okay, so this is not very this is for this. Okay, beta 1. Okay, then alternatively for this there is and one more term, it is standard error of beta 1. This is nothing but the this divided by small sigma divided by then yes root of small sigma divided by root of sigma xi square. Okay, so variance and standard error both are the same things. Okay, so variance root of the variance is standard error. Okay, so alternatively we use variance and standard error. In some econometric package they are giving standard error, or in some package they are giving variances, in some package they are giving both variance and standard error. Okay, so whatever may be the variance and standard error, it both will convene the same idea. That means measuring the standard, measuring the variations or measuring the accuracy of the estimator or measuring the reliability of an estimate. Okay, then similarly we can find out the variance of beta 0 and standard error of beta 0. How we can find out variance of beta 0? This is there's a some big yeah, standard deviation square, okay, into sigma capital X square divided by, okay, n into sigma small x square. Okay, then if you find out the root of this beta 0, then you will get variance of beta 0, you will get the standard error. Okay, then what is this value? What is this value? Small sigma, it is nothing but the standard error of the regression model. Okay, so it is nothing but RSS divided by n minus 2. What is n minus 2 here? N is total number of observation, 2 means total number of variables. So we are having only 2 variables, so it is RSS divided by n minus 2 and it should be under root. Okay, yes, should be under root of RSS divided by n minus 2. Okay, so we can find out this value. Okay, we can find out this value. First we have to find out this value. Okay, how we can find out? Square root of SQRT, square root of RSS, this is the RSS, okay, divided by 8, 11.43. What is standard error? 11.43. Okay, yes. Now we can find out these values. Okay, first variance of the beta 0, beta 1. This is the small sigma divided by sigma small x square. Okay, this is the small x, then this is the small x square. 0.000347. Okay, then what is standard error? This divided by square root of SQRT of variance or SQRT of sigma xi square. Yes, 0.062961. Okay, so this is the way how we can find out the variance of beta 1 and standard error of the beta 1s. Okay, then for finding out this variance of beta 0, we have to find out capital X square that we have not found so far. Okay, so this is the capital X, you square it 6,400, then you do it for all, then you sum it. Okay, yes, now we have got it. Okay, so we can do, yes, standard smart sigma square, okay, into sigma x square, capital square, so this is the sigma. Okay, there's a mistake, wait, yes, it's equal to this square 130. Okay, so 130 into sigma x square. Okay, so very big values. Okay, no problem. Then you find out n into, n means 10, 10 into sigma xi square, 30,000, 33,000. Okay, we have got 33,000 something like that. Now we can find out. Okay, so this is equal to this divided by this. Okay, how much we have got? It is 127.6454. Okay, then what is the, if you find out the square root of this, 11.2980. Okay, so 11.29802. So this is the way how we can find out the variance and standard error of the regression model. Okay, so far we have checked goodness of it and precision or accuracy of the statistical test, or accuracy of the parameters. Okay, now what we have to go, what I am going to find out is, now we have to do hypothesis testing. Okay, hypothesis testing about the slope parameters. Okay, so individually and uh, jointly we can test the hypothesis. Okay, so in simple regression model in SLRM there will be only one slope coefficient, so there will be only one coefficient. Okay, or one slope coefficient, one intercept. So individually we can uh, check the hypothesis. Okay, using t-test. Okay, whereas in the case of MLRM, there will be more than one slope coefficients. So you can check whether all the coefficients are significant jointly using F test. Okay. Okay. So in SLRM, in simple regression model, T test and F test will be give you the same answer. Okay. Yes. So we have to go for testing the individual uh, test or individual significance of the each slope coefficients. So for that what we have to do, we have to first we have to create h0 and h1. What is h0? H0 means that this y and x are not related. When we will get such kind of a things, when our beta 1 is equal to 0. Okay, so we assume that beta 1 is equal to 0, it's our null hypothesis. Okay, so alternatively you can hypothesis beta 1 not is equal to 0 or beta 1 less than or equal to 0, more than or equal to 0. Okay, depends upon your theoretical frameworks or your introspection. Okay, yes, beta 1 is equal to 0 and beta 1 is for time being I'm just giving beta 1 not equal to 0. Okay, so if I am just giving equal to not equal to, then it will be a two-tailed test. Two-tailed test. Okay, so two-tailed test can be determined by just looking at the symbol in the alternative hypothesis. So in alternative hypothesis it is not equal to sign, so our test will be two-tailed test. Okay, yes. So how we can find out the t value? Okay, for this value we have got beta 0 is equal to, yes, 17.5. Okay, then beta 1 is equal to 0.573, something like that. We can find out whether these two values are individually significant or not. How we can do that? Using t-test. Okay, so beta 0 or t beta 0 and t beta 1. Okay, so t beta 0 means that, how we can find out this question? It is nothing but your beta 1 value, sorry, beta 0 value divided by standard error of this beta 0. Okay, so it is 1.55. In beta 1 this is the value divided by 0.062 something, yes, 9.106104. Okay, so the values are 1.551894 and 9.106104 or 9.10 something like that. Okay, so it is nothing but t values are your slope value divided by standard error. Okay, t values are nothing but t value is equal to your slope value divided by standard error. Okay, so we have find out the value for t for both beta 0 and beta 1. Okay, now how we can check whether these t values are significant or not? For that we need to have table values. Okay, so t table value we need table value. Okay, so how we can find out t table values? Using equation, okay, using the t inverse. Okay, there's a 2 in t inverse and t inverse 2t. Okay, since we are following two tail test, our command will be t inverse 2t. Okay, then you have to give the probability. Okay, probability means what? I am assuming 0.05, that means I am 95%, I am assuming 95% confidence level, and my type 1 error will be only 5%. Okay, the degrees of freedom n minus 2 is equal to 8, 2.306. Okay, so what is the decision? Decision is if t values are greater than table value, you reject the null hypothesis. Okay, so look at this one, actual value 1.55, table value is how much? Yes. Okay, table value is actual value is 1.55 and table value is 2.30. Okay, what you have to do, actual value, actual t value is not greater table value, so we have to accept the null hypothesis. Okay, so here in second case we have to reject the null hypothesis. Okay, but look at in regression model, simple regression model, our hypothesis is whether beta 1 is significant or not. Okay, because beta 1 only will give you whether there is a relation or not. Okay, so no need to look at these things, you only look at these t values of the beta 1. Okay, and always the intercept will never give you a coefficient which is significance or which has a meaning. Okay, sometimes it may give some other things which will not have any meaningful any meaning. Okay, so here we can reject the null hypothesis. Okay, then we reject the null hypothesis. What does it mean? It means that there is that means y and x are related. Y and x are related. Is it okay? Yes. So in that way we can find out the t values. Okay, or alternative to this t value, we can also use confidence intervals. Confidence interval of beta 0 and confidence interval of beta 1. What is this confidence interval? It is nothing but we will get a lower limit and upper limit, or lower bound and upper bound. Okay, so if your actual t values lies in between these two limits, then you can reject the null hypothesis. Okay, yes. So how we can find out that one? Lower limit is equal to, okay, beta 0. Okay, beta 0 means this minus, okay, then standard error of beta 1 this is a standard of beta, sorry, beta 0, okay, into, okay, t values, the t which you have got 230 minus 8.519, yeah, okay. If you just do the same thing, but instead of, yeah, what you have to do is equal to, this is the beta 0 plus this is the standard error into this is the t value. Okay, so if your values lies in between minus 8.519 and 43.585, you can make a decision on the basis of these things. Okay, similarly you can also find out the confidence interval of the second things. Okay, how you can do this? Equal to your at beta 0, so yeah, beta 1, 0.573 minus then standard error of beta 1 into table value 0.428, then next will be beta 1 plus 0.629 into your t values 0.7182. Okay, so if the values are in between these two, you can take a decisions. Okay, yes, then one more thing is there, one more test is there, or one more value which is very powerful in statistical hypothesis testing, called p value. How we can find out the p value? It is very simple. Okay, so p value is what? P value is nothing but the smallest level of significance at which we can reject the null hypothesis. So how we can find out it? T distribution, okay, t distribution, yes, your t values, okay, for first things beta 0, this is okay, t value, comma, degrees of freedom is n minus 2, okay, 8, comma, oh, you can do one thing, t distribution two-tailed. Okay, so it is this is the one value, comma 8, okay, 0.159, and the same thing for this is p value for beta 0, okay, so beta, yes, beta 0, and this is beta 1, this will be t distribution two-tailed, okay, then x is the 9 point something into, sorry, comma 8. Okay, so this is very close to 0. Okay, if you just find out the value, it will be very close to 0. You format the cell for number. Yes. Okay, so what does it mean? In the first case, we can only reject the null hypothesis at 100 or 1 minus this one, only 84%, or only for 84% confidence you can reject the null hypothesis about beta 0. But here this is 1 minus 0, 1 minus 0, that means 1. Okay, that means 100% you can reject, you are 100% sure that you can reject the null hypothesis. Okay, so this is all thing about the simple linear regression model. Okay, so this is how we can find out manually all the estimation procedure and the hypothesis and evaluation test of simple linear regression model. Okay, yes. Now in Excel there is a command, or there is a inbuilt software or inbuilt program for doing this regression. Okay, no need to do all these things with a single click. You will get all these informations. Okay, for good data analysis, there's a regression. The command is regression is there. You just click OK. Okay, then you select the Y range. Y range means your dependent variables. Okay, then you select your independent variables. Okay, then you click labels. Okay, then you just click OK. Look at all the things that we have found is given here. Okay, so r square is 0.912. R square is 0.912. Okay, you look at what we have got. Yes, 0.912. Okay, now standard error 11.43. What we have got? 11.43. Yes, 11.43. Okay, now observations 10. Okay, then this is nothing but r correlation. Okay, y correlation between y and x. Okay, that's not important for us. Now this is okay. This is 1847. This is nothing but regression sum square or estimated sum square, or what we call ESS. Look at what we have got. ESS, we have got ESS 10847. Here also 10847. Then this is residual sum square. This is RSS, residual sum square 1046. Yeah, how much we have got? RSS, yes, 1046. Then this is total sum square. This is TSS 11894. How much we have got? Y square, small y square. If you sum it, no, sorry. Yeah, 11894. Here also 11894. Okay, yes. So this is the f value. Okay, that's not important for simple regression model. Okay, but when we discuss about this multiple regression model, we discuss what is this f and all. Okay, then look at coefficient 1.753, and so this is intercept, this is slope. Okay, so 1.573, 0.57. Look at what we have got. Yes. Okay, yeah. Then look at standard error. What we have got? 1129 and 0.629. Look at what we have got. 1129 and 0.629. Okay. So in regression, they are reporting the standard error, not the variance. Now t-stat 1.55, 9.106. What we are getting? Yeah, what's that? Yeah, look at this value, what we are getting. Yeah, we are getting the same value. Okay, then p-value 0.59 and 1.7 e, that means 0. What's the p-values? Yeah, 0.159 and 0.000. We are getting the same p-value. Okay, then look at this value. This is also minus 8.59 to 43.58. Okay, and 0.4289 to 0.718529. Okay, so from this what we can understand that, okay, the intercept we cannot accept, or we cannot reject. So we can, even though the regression is good, in terms of goodness of fit and various statistical tests, we can only explain or we can only interpret the slope coefficient because only the slope coefficient is significant, okay, but the intercept coefficient is not significant. Okay, so this is the way how we can do the regression analysis manually using regressions and also using the analysis tool pack, data analysis tool pack. I hope that you have enjoyed. Okay, so you can also do the same experiment using the same data, and you can see how it look like. Okay, so thanks for watching this video.